Hello everyone. Welcome to our class of AWS for learning the brief of Amazon Web Service. This is a beginner level class. So if you're planning to learn about Amazon Web Services, then you are in the right place. Because in this class, we will cover everything to get you started with learning about AWS. Let's take a look what you will learn from this class. Introduction, Cloud Computing Fundamentals, how cloud computing helps, what is cloud computing, cloud services models, SaaS, PaaS, IaaS, cloud deployment models, cloud computing myths, cloud service providers, AWS career, role-based certification, AWS certification, AWS global infrastructure, AWS core service domains, AWS free tier, and AWS console, AWS compute service, AWS elastic load balancer, types of elastic load balancer, AWS auto scaling, Amazon EC2, Amazon EC2 instances, Amazon EC2 instance types, Amazon Elastic Block Store, Amazon S3 Glacier, AWS Security Services, AWS Database Services, AWS Networking Services, AWS DevOps Services, which is the last one. After completing this class, you'll be able to understand cloud computing basics, identify benefits of cloud computing, differentiate between SaaS, PaaS, and IaaS, recognize cloud deployment models, public, private, hybrid, and also explore AWS career opportunities. Understand AWS role-based certification, learn AWS global infrastructure, use AWS free tier and AWS console, work with AWS compute services and elastic load balancer, implement auto scaling, and manage Amazon EC2 instances. This is a project-based class. So during learning, you will have class project. So what you have learned, you'll be able to participate in class project and practice while you are learning. You will have supporting resources in this class, so it will be easier for you to learn. During learning, if you face any issue or if you have any question, then feel free to ask me. I'm always there for you to help you out. So let's start learning AWS together. Welcome to a new course of AWS. Before getting into our course, we're going to learn about the introduction to AWS, which is Amazon Web Services. Well, what is AWS? So the overview of AWS, or Amazon Web Service, is a comprehensive and widely adopted cloud platform offering over 200 fully featured services from data centers globally. AWS is used by millions of customers, including startups, large enterprises, and leading government agencies to lower the cost, become more agile, and innovate faster. What are the key components of AWS? Computer services. There are a couple of things which we are going to know in this class or in this introduction part of the course. Make sure not to skip any because this whole course is going to be more theoretical than practical. So make sure not to skip anything. In compute services, we have EC2, which is Elastic Compute Cloud, which is a virtual services to run various applications. Then we have is Lambda, run code without provisioning or managing servers. ECS, which is Elastic Container Service, which is highly scalable container services. Then we have is EKS, which stands for Elastic Kubernetes Service, which is managed by Kubernetes Service. Then we have is Storage Services. S3, which is Simple Storage Service, Scalable Object Storage. Then we have is EBS, which is Elastic Block Store, which is a persistent block storage for EC2, which is also found in compute service on the first point. Then we have is Glacier, which is a low-cost archive storage, which is used mostly to store a lot of data. Then we have is Database Services. RDS, the full form of RDS is Relational Database Services, which is managed by Relational Database Services. Then we have is DynamoDB, which is NoSQL Database Services. We're going to go through them step by step. So if you're confused, make sure not to skip any part of the classes, and I'm going to give you a brief about everything. Then we have is Aurora, which is MySQL and PostgreSQL compatible relational database, which mostly works with data services online. Then we have is networking. We have VPC in networking, which is a virtual private cloud, which is used mainly by AWS, and they don't have only one. They have a lot of it so that they can use it for isolated networking resources. Then we have is CloudFront, the content delivery networking, which is CDN, which is found in CloudFront. Then we have is Route 53, which is a scalable domain name system, which is the DNS of that specific service or that server. Security and Identity, which is IAM. IAM stands for Identity and Access Management, which helps you to securely manage the access inside of that server when you are there. Then we have is KMS, which is Key Management Service, which is used to create and manage encryption keys. Obviously, you will not be able to create a key on your own without having that encrypted, because that is for your own security. If it's not encrypted, you will lose your own security very fast. And obviously, by this time or in this modern age, it is also very highly that your account, which has a lot of assets, is going to be taken down. Then we have is Shield for our security and identity, which is managed DDoS protection. Then we have is Analytics. We have Athena, which is used for query data in S3 using SQL. Well, those of you who don't know what SQL is, well, this is the database type of programming, not even a programming, it is a kind of a language used by PHP to manage out the databases inside of the server or inside of your own DNS. Then we have is Redshift. Redshift is a data warehousing service which is used to actually store a lot of data inside of a specific server or inside of that specifically known data warehouse. Then we have is Kinesis, which is a real-time data streaming platform. Not even a platform, it is also a type of a service which is given by AWS. And that is why AWS has almost like 200 type of services given by their own. Then we have is machine learning. First off, we have SageMaker, which is used to build, train, and deploy ML models. Then we have is recognition, image and video analysis, which is also used by AI most of the time. Then we have is comprehend, which is a natural language processing service. Then we have is developer tools. First off, we have code commit, which is used for source control services. Then we have is code build. You can also build and test codes inside of the AWS server. Well, if you don't know or if you're still confused about it, well, you don't have to be, because I'm going to open everything up step by step in this whole course. Then we have is code deploy, which is an automate code deployment service. Then we have management and also governance. Just like I said from the beginning, that AWS offers a lot of services and it also services or helps the government too. Now, management and governance are the first one we have is CloudWatch, monitoring and logging services. Well, it is used worldwide, not just in AWS, but also other services online which you get. Then we have is CloudTrail, which is also used in AWS, which is used to track user activity and API usage. Then we have is config, which is a track resource configurations. Well, obviously, if you want to change path, change the trajectory, then obviously you have to configure some. So you also get the config service. Then we have is application integration. Obviously, if you have the services, people who are new or people who want to get directly into those services or directly want to get into those works will not be able to work unless there are a couple of applications integration. So first application integration, which is the most simple one, is called the SNS, and it also stands for Simple Notification Services. When you are working on any specific server or any specific application, obviously you're going to need an SNS. Well, this is integrated on most applications given online or most applications that are available right now in this time. It helps you to relay the messaging services. Then we have is SQS. It stands for Simple Queue Service, which is used for message queuing. Obviously, it will not be able, or a service or even a server will not be able to send like thousands and millions of messages at the same time. Obviously, it's going to get delayed just a bit, or let's say step by step or one by one, but consecutively. So the SQS comes in handy, which actually queues up the service or queues up the messages and then sends it at the right time. Then we have step functions, coordinate distributed application. Okay, now what are the benefits of AWS? The first benefit of AWS is the scalability. It automatically scales application up or down. Well, all the things which you've seen about AWS up till now, all of them apprehends or also amplifies and also has their own type of significance on another service. So due to that, you have that scalability option. Then we have is cost efficiency, pay as you go pricing models. Obviously, you will find out a lot of models online or a lot of models in AWS, but it's going to depend on what you want to make or what model you want to make. The higher the services are, the higher you pay. The lower the services are, the lower you pay. But it doesn't mean the lower you pay is going to be bad. It depends on what type of service you want to make out of AWS. Then we have is security, which is used for strong security capabilities and also compliance. Global reach, availability in multiple regions worldwide. Obviously, there are a couple of regions that still do not have AWS, but you will obviously be able to get the benefit of AWS from anywhere in the world. Then we have is innovation, which is a continuous introduction of new services and features. So the conclusion of AWS is that AWS provides a robust cloud platform to meet diverse computing needs, offering services for compute storage, databases, machine learning, and even more. Its extensive service portfolio, scalability, and security make it a go-to choice for organizations looking to leverage cloud technologies for innovation and also efficiency. So, this is the end of the introduction of the course of AWS. So, I'm going to tell you once again is that this course is going to be mostly theoretical based. So, most of the classes you will see in this course will have a lot of presentations which you have to learn as a lecture, because there are a lot of things to learn in AWS and really a less practicals which you can apply on after learning everything about AWS and everything about every services which AWS has to offer. So, hope you understood everything about this class, and if you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So hope to see you guys in my first class of AWS. Welcome to our first class of AWS. In our first class, we'll learn everything we need to know about cloud computing fundamentals of AWS. Well, if you've seen my first introduction of AWS, well, you will already know a couple of things about it because there's going to be a lot of the things which I've recapped in this class because I've made a brief about it. Okay? So without any further ado, let's move on with our class by knowing what cloud computing fundamentals of AWS are. Cloud computing is the delivery of computing services, including servers, storages, databases, networking, software, analytics, and intelligence over the internet, which is also known as the cloud. And that is why it is called the cloud computing. To offer faster innovation, flexible resources, and economies of scale. So, now let's get into our key concepts, which are also quite similar to AWS. First off, we have on-demand self-services. Users can provision computing resources as needed automatically. You don't need to work extra time on these services. Those are going to be automatically based just by using algorithms and even AI by this time, without requiring human interaction with each service providers. Then we have is broad network access. Services are available over the internet and accessed through standard mechanisms that promote use by heterogeneous thin or thick client platforms. Well, all of those are also automatical because obviously there are a lot of gateways which people can get through, and all of them cannot be interacted with human. So all of the services which are on the cloud service act on it so that you get the broad access networking. Then we have is resource pooling. Providers computing resources are pooled to serve multiple consumers using a multi-tenant model, which is also an algorithm or a program. Okay? Then we have is rapid elasticity. Capabilities can be elastically provisioned and released to scale rapidly, outward and inward, commensurate with demand. Then we have is measured services. Cloud systems automatically control and optimize resources used by leveraging a metering capability, providing transparency for both the providers and also consumers. Obviously, if the service which you're taking is not liable or is not trusted, obviously you will not be able to use that, or people will not actually get into that service much often. To make sure that it is transparent, it is also done by a cloud system which automatically controls it and also interacts with you. Another thing which you need to know over here is about the optimization. A lot of services get together, a lot of services imply on one another and actually optimize your resources and also the resources given into the algorithm, and it also leverages the metering capability of it. Obviously, if you put in something or if you try to get into or get an access of something which you cannot get access or a normal person cannot get access, you will not be getting inside. Obviously, the metering capability comes in handy in this stage. Now, let's move on to our AWS Cloud Computing Services. Compute Services. EC2 Elastic Compute Cloud, which provides resizable compute capacity in the cloud, allowing users to run virtual servers instances as needed. Well, in my previous class or in the introduction, I've given you a small detail about each and every one of them, but I'm going to break them down and also briefly describe what they are actually used for. Then we have is Lambda. Allows user to run code without provisioning or managing the server. Obviously, if a user is getting into the server and wants to get service, obviously not all the users will be able to run the code. So to make it more beginner friendly and so that it makes it user friendly, it is used by Lambda, or Lambda actually makes it easier for the users. So users pay online only for the compute time consumed. and the rest of the time, which the user is not using, they will not pay for it. Then we have is Elastic Beanstalk, which is an easy to use service for deploying and scaling web applications and services. Now you might think that this type of web application or a service or an app will only be used by AWS. No, if you want to make your own type of service, or if you want to get the help from these services and make your own web application, you can also do that. And you will be able to get that help from this Elastic Beanstalk service. Then we have is storage services. There are a couple of them, but most of them are very common. We have S3, which is the simple storage service, which provides the scalable object storage for data backup, archival, and also analytics. So you can think, or you can also come to conclusion that S3 is one of the most important one for actually the storage of data backup. Then we have is EBS, which is Elastic Block Store, which provides persistent block storage volumes for use with EC2 instances. So this also complements EC2, but it uses a specific small storage and of specific volume so that you can use it online. Then we have is Glacier, which offers low-cost storage for data archiving and long-term backup. Obviously, when you are making an online service, it's going to take up a lot of space, because if you see that you are getting a lot of users, obviously they're going to put their own resources inside of your server. Then what you have to basically do is make sure that you have a very big storage or a very big server where it can be stored. So Glacier comes in handy in those cases. Then we have is database services. Starts off with RDS, which is Relational Database Services. It actually simplifies setting up, operating, and scaling relational databases inside of the cloud. Obviously, if you just put in your data, it's not going to put in the data inside of your service just like that. It's going to obviously crack down what it actually means so that the algorithm or the program can understand what the user wants. So it actually simplifies the setting up and also the operation. Then we have is DynamoDB, which is a fast and flexible NoSQL database services for single-digit millisecond performances. Obviously, you can say something like a boot up, something like a search. Well, those things come in handy when DynamoDB is in use. Then we have is Aurora, which is a MySQL and PostgreSQL compatible relational databases, which is built for the clouds for the database services. This is a genuine service, which is Aurora. Then we have is networking. We have VPC at the beginning, which is a virtual private cloud, which is also used by EC2 most of the time. Then we have is that it allows user to create isolated networks within the AWS cloud. Obviously, when someone is making a service to give it out, okay, then it also has a high tendency to get cracked in or to get, let's say, a breach inside of that server. So it basically allows users to create an isolated network within the AWS cloud so they do not get out of that specific storage or that specific limit. Then we have is Route 53, which is a scalable domain name system, which is DNS, which is also a web service. Obviously, if you want to scale your domain, obviously you have to use Route 53. Then we have is CloudFront, which is a fast content delivery network, which is also known as CDN, which is a service that securely delivers data, videos, application, and APIs to customers globally. Well, just in case as an example, if you are searching anything on Google, Chrome, or any web browser, you get the result, right? Such as a video, such as a couple of links, maybe even images, news, and everything. So you can think of CloudFront something like that service. But what it basically does is that it delivers the data, video application, and APIs to the customers globally when they are using the AWS service. Then we have is security and identity. Starting off with IAM, which is identity and access management. It enables you to manage access to AWS services and resources securely. Then we have is KMS, Key Management Services. Makes it easy to create and control the encryption keys used to encrypt the data when a person or when a user or a customer wants to get inside and get in the access of that specific service. Then we have is Cognito. Provides users sign up, sign in, and access control. Well, that is the work of Cognito. Then we have is Analytics. Athena, an interactive query service that makes it easy to analyze data in S3 using the standard SQL, which is used for data management or database. Then we have is Redshift, which is a fast, fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and existing businesses intelligence tool, such as Analytics tool and all of those. Then we have is EMR, which is Elastic MapReduce. Produces a managed Hadoop framework that makes it easy, fast, and cost-effective to process vast amounts of data across resizable clusters inside of your service. Then we have is machine learning and also AI. Now we are going to know about SageMaker, which is a fully managed service that provides every developer and data scientist with the ability to build. So just in case, as an example, you could be creating yourself your own program, your own application, and SageMaker basically helps you for that, which is also used for training and deploying machine learning models very quickly. Then we have is Rekognition. Analyzes images and videos for facial recognition and object detection, which is also used for security most of the times nowadays, such as Face Lock, Face ID on your phones, or even on your devices. Then we have is Comprehend, which is a natural language processing, which is NLP in short, which is a service that uses machine learning to find insights and relationships in text. Well, relationships is basically kind of like the link of the text and how the algorithm actually understands it. Then we have is the developer tools, Code Commit, which is a source control service that makes it easy for teams to host secure and scalable Git repositories. Then we have is Code Build, which is a fully managed build service that compiles source codes, runs tests, and produces software packages that are ready to deploy. Then we have is Code Deploy, which is at the end, which automates code deployments to any instances, including EC2 instances and server running on premises. Then we have are the last two ones, which are management and also governance. The CloudWatch, which provides monitoring for AWS cloud resources and the applications you run on AWS. CloudTrail enables governance, compliance, and operational and risk auditing of your AWS account. The Config provides AWS resource inventory, configuration history, and configuration change notification. Well, obviously, if you have done anything inside of your server or your service, obviously you need the configuration change and also you need the notification so that you are notified. Then the last one or the last service we have is application integration, SNS, simple notification service. This is a managed service that provides messages directly from publishers to subscribers, such as sending a message to the customers from the sellers. Okay. Then we have is SQS, which is simple queue service, which is a fully managed message queuing service that enables you to decouple and scale microservices, distributed system, and also serverless applications. Well, obviously, SQS also works offline. Then we have is step functions. Makes it easy to coordinate the components of distributed applications and microservices using visual workflows. Hope you understood everything about this class on how the cloud computing service works. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to another class of this course of AWS. In this class, I'm going to show you and I'm also going to describe everything with examples of helps in AWS. Well, in my past two classes, I've shown you about the services which you can get from cloud computing and also AWS. Now let's get brief into the examples of how those functions or how those services actually help. First off comes the scalability and also elasticity. The example of scalability and elasticity is auto-scaling for EC2 instances can automatically adjust the numbers of instances based on traffic. Now, the traffic is going to depend on how many people are trying to get or search a specific type of product, or even trying to get that specific type of resources from the services which you are going to make. Then we have is that ELB ensures your application can handle increased load by distributing it across multiple services. Obviously, if you make, let's say, a web application or maybe even a service, and obviously it's going to have a specific limitations of the traffic because it also has the tendency to crash at a certain stage. So to make sure that it does not crash and it can handle the increased loads of the traffic and also the resources distribution, it uses multiple servers and also multiple services, which will make it a lot more compatible. Then we have is cost efficiency and how it actually helps. The first example which you see is with S3, which is also a storage. You can pay online for the storage you actually use. Let's say if you want to use a specific storage, maybe just in case, let's say 1 terabyte, you are only going to pay online for that amount of that specific storage or how much it is going to cost. If it exceeds that specific limit, it's going to suggest you to get another storage or get another server and then work along so that it does not cause any issue. Purchasing reserved instances for EC2 can save up to 75% over on-demand pricing. So make sure to use the EC2 instances so that you can save up more and then also get up more storage when you actually need it. Then we have is flexibility and also the agility. The first example which you see over here is that you have to choose between a variety of database services like RDS, DynamoDB, or Aurora based on your application's requirements. So obviously, not all of the applications what people make or the users make are going to have everything which you see over here, such as RDS, DynamoDB, or even Aurora. It's going to depend on what type of application it is and what type of requirement does it need. If it needs RDS, use and only pay for RDS. If you need Aurora, use and only pay for Aurora, or even if it's for DynamoDB. Okay? Then the next example about flexibility and agility we can see is that use Route 53 to route end users to the nearest data center for better performance. Let's say, as an example, you are working on a specific server. Obviously, you will try to use the server which is the most closest to you, which is going to give you the best and the fastest data like interaction, okay? Because if your server or if you are selecting a server which is very far away, it's going to be delayed and the data performance or the data, let's say, interaction between them is going to be very slow. So make sure to use Route 53, which automatically selects the nearest data center for the best performance. Then we have is security and also the compliance. The example of security and compliance is that the AWS Key Management Service, which is also known as the KMS, helps you to create and control the encryption keys used to secure your data. It is also encrypted inside of the server, obviously, because if the algorithm and the SQL, or let's say MySQL, just in case, which takes in your database or which takes in the data and also recognizes who the user is. So, as an example, the AWS Key Management Service helps you to create and control the encryption keys used to secure your own data so that you can get inside and get the access. The next example of security and compliance is that use AWS IAM to manage access permission to your own resources. Obviously, you don't want anything excess or extra which you do not need. So if you want to use only the resources or the permissions which you have to use for your own benefit, use AWS IAM service to get that access and also to get that resource. Then we have is innovation and integration. The first example of innovation and integration is that Amazon SageMaker simplifies the process of building, training, and deploying machine learning models. Well, we've been talking about SageMaker for the past two classes. So it basically turns or actually breaks down the codes or the data which you want to get, or even a specific requirement which you want to get from that specific service or that specific server. Well, SageMaker actually breaks down that command or that statement into a code so that it actually simplifies the process of building, training, and also deploying the machine learning models. Well, you can also make your own model just by using SageMaker service. Then we have is use step functions to coordinate microservices and manage application workflows. So make sure to do that. Then we have is reliability and also availability. The example of reliability and availability is that multi-AZ deployments for RDs automatically create a primary database in one AZ and synchronously replicate it to a standby instances in a different AZ. Well, you might be confused by it, but you don't have to worry because I'm going to break it down from class to class. The next example of AWS backup basically simplifies and automates backup tasks, ensuring data is protected and easily recoverable. So obviously you are not going to use a service where you have the chance to lose your data. So obviously the AWS backup is also very good and also top notch. It automates backup tasks and also ensures the data is also protected at the same time. And even if you lose it like accidentally, it can be easily recoverable. Obviously, all the services come in handy in this case. Then we have is developer productivity. The first example of developer productivity is that AWS code pipeline automates the build, test, and also deploys phases of your release process every time there is a code change. Obviously, a user is not going to get the same product over and over again, maybe in bulk. But if there is a code change inside of that pipeline, then it basically helps, or let's say the AWS code pipeline automates the build, test, and deploy phases of your release process. Okay? So basically what happens is that it does not delay anything, but it releases the process every time there is a code change. So it just basically gets to those who actually needs to change it as soon as possible. With AWS Lambda, you can run code for virtually any type of application or backend services without managing the servers. Obviously, you are going to build a server, or even for AWS Lambda, it has created up an algorithm or a program which can actually run a code virtually in any type of applications or backend service without even getting into another program or building another program or another code or another pipeline. So now you know about how these examples actually work. Now let's get on to the conclusion. Well, basically, the cloud computing with AWS provides unparalleled benefits in terms of scalability, cost efficiency, flexibility, security, innovation, reliability, and developer productivity. By leveraging AWS's comprehensive suite of cloud services, businesses can focus on core activities, innovate faster, and achieve greater operational efficiency and also agility. So basically, if we come to the conclusion, or if we make it a lot more shorter, is that when any business is trying to get into the AWS cloud computing services, they can only focus on their innovations and their own problems, or maybe even their own benefits, without even thinking about the cloud computing services. Because cloud computing services is made in such a way that it is very reliable and is also the most used services online right now in 2024. So hope you understood about everything in this class on how cloud computing with AWS actually helps and how these examples actually helped you to understand about cloud computing and also intertwined with AWS at the same time. So thank you for watching this video again and hope you understood about everything. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to another class of AWS course. In this class, I'm going to show you and tell you everything you need to know briefly about cloud computing. Well, this is not going to be a class where it is going to be intertwined with AWS, but I'm going to show you everything you need to know about the basics of cloud computing. The definition of cloud computing is the delivery of various services over the internet, including storage, computing, power, databases, networking, software, analytics, and intelligence. Instead of owning and maintaining physical data centers or servers, businesses can access these resources on demand from a cloud provider. So, let's get into the key characteristics of cloud computing. On-demand self-service. Users can provision computing capabilities as needed automatically without requiring human interaction with the service providers. Well, obviously, from here, you can see that these type of services are on demand and also self-serviced. So it means that you don't have to go anywhere and also you don't have to stay in line to get those services because these services are used every day, every single second in this world. The example of using this is that spinning up a virtual machine in minutes through a web interface, which actually saves up a lot of time, a lot of labor, and also a lot of strategy. Then we have is broad network access. Services are accessible over the internet and can be used through standard devices such as laptops, mobile phones, and also tablets. The example of broad network access is that accessing cloud storage from any device with an internet connection. Let's move on to the next one, where we have is resource pooling, which is one of the most important thing when you have to get inside a specific amount of data. Cloud provider pool with their resources to serve multiple customers using a multiple or multi-tenant model with different physical and virtual resources dynamically assigned and also reassigned according to the demand. So it's going to depend on what the person is searching for and what the person is actually looking for. The example of this is that multiple customers using the same physical servers but isolated through virtualization. Even if you want to get the same service and let's say another person or even let's say a lot of person is trying to get the same service, well, you don't have to wait and neither is it going to be delayed because it's going to help you to create a new virtual environment for you to use that service just on your own when you are using the internet and also your own device. So it just basically creates up an environment for you so that you can get the full service through that server. Then we have is rapid elasticity. Resources can be elastically provisioned and also released to scale rapidly outward and inward commensurate with demand. The example of this is that you can automatically, by adding more servers instances during high traffic periods and scaling down during traffic or low traffic. So you have to keep that thing in mind. Due to it or due to the service having the rapid elasticity, you can also get access anytime, even if there is high traffic period and even there is low traffic period. But sometimes you might sometimes like face a couple of errors or maybe sometimes face like something with an error saying request timed out. So you have to keep that thing in mind and use it when there is low traffic so that you get the best service. Okay. Then we have is measured service. First off, we have is cloud system, which automatically controls and optimizes resources used by leveraging a metering capability at some level of abstraction appropriate to the type of service. Example, let's say storage, processing, and bandwidth. So why are these examples termed in this measured services? Well, storage, processing, and also bandwidth comes along and plays in the same role. Without bandwidth, you cannot process. Without the process and without the bandwidth, you cannot use the storage. So make sure that your bandwidth and the processing and the storage is of the best quality and is of the best notch. And obviously, cloud system or the AWS cloud system basically gives you the best service out of any other ones. The example of this is that paying for cloud storage is based on the amount of data stored and the duration of that specific storage. So you are going to be buying a specific storage for your service and as a virtual environment or as a virtual storage on the cloud or on the DNS. What are the types of cloud computing? Let's get into that. Infrastructure as a service, which is known as IaaS. It provides virtualized computing resources over the internet. So just like I said, that it's going to create a virtualized computing resource and it's also going to create a virtual environment for you so that you can work on your own fully protected. The example of this is that Amazon, EC2, Google Compute Engine, and a couple of them. The use cases of IaaS is that it is used for hosting websites, running enterprise applications. Then we have is platform as a service, which is known as PaaS. It provides a platform allowing customers to develop, run, and manage applications without dealing with the underlying infrastructure. So even if you don't have the team, or even if you don't have a lot of people to work on your platform, you can easily use PaaS, which is platform as a service, so that you don't have to deal with the underlying infrastructure. Then we have is example. The example of PaaS are Google App Engine, Microsoft Azure App Services. The use cases of PaaS is for developing and deploying web applications online so that other people can get access to them and so that you can also create your own system or your own server. Then we have is software as a service, which is SaaS. It delivers software applications over the internet on a subscription basis. So obviously you have seen a lot of softwares that has a lot of subscription. In case Microsoft Office Suite, then we also have like Adobe. Then we also have a couple of other, maybe let's say Netflix. Then we also have Spotify. Those are the type of SaaS. The example of them are Google Workspace, Microsoft Office 365, and just like I said, so on. The use case of SaaS is for email, customer relationship management, which is also known as CRM in short, which is also one of the mostly used service right now. Okay. Then we have is function as a service, which is also known as FaaS, which provides a platform for running code in response to events without provisioning or managing the servers. Well, a lot of people who are trying to get into the service type of businesses or maybe even trying to get in so that they get best performance or even trying to help. So a couple of people don't know how to run codes in these platforms. So in these cases, FaaS comes in handy for events without any provisioning or any managing servers. The example of these FaaS are AWS Lambda, Azure Functions, and a lot more. The use cases of AAS or FaaS is running microservers, real-time data processing, which is also similar to MySQL and also PHP. The deployment of them are public cloud. Services are delivered over the public internet and also shared across multiple organizations. Well, that is the public cloud. The example of a public cloud is the AWS, Microsoft Azure, Google Cloud Platform. The use cases of public cloud are scalable resources for dynamic workloads, general purpose computing. Well, most of the software which you see right now, maybe even running on your PC, most of them are of the public cloud. But when you're using a private cloud, that is a whole different thing. So let's move on and learn a bit about what the private cloud is. So cloud infrastructure is dedicated to a single organization and not shared with others. So this is more private and also has a lot more privacy measurements. The example of private cloud is private data centers or hosted private clouds, maybe even a server of any corporation, including or having all of its data and servers, maybe even having the data of any employee, and those are the example. The use case of having a private cloud is highly regulated industries, customized infrastructure needs. Then let's move on to our next clouds, the hybrid cloud, which combines public and also private clouds at the same time, allowing data and also application to be shared between them. The example of having a hybrid cloud is using public cloud for non-sensitive workloads while keeping sensitive data in a private cloud or in a private server. The use cases of private cloud is disaster recovery, load balancing between clouds, and it is also used by the government of most countries. Then we have is multi-cloud. The use of multiple cloud services from different providers is called a multi-cloud. The example of a multi-cloud is using AWS for IaaS, Google Cloud for PaaS, and Office 365 for SaaS. The use cases of multi-cloud is for avoiding vendor lock-in, optimizing cost, and also its performance. So hope you understood everything about this cloud or everything about this class on AWS and also cloud computing and also couple of brief about couple of cloud services. If you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to another class of AWS course. In this class, I'm going to show you and I'm going to tell you about the briefs of the cloud services models offered by AWS. And those are going to be SaaS, PaaS, IaaS, and also FaaS. This is going to be a very important class to understand about these models, and these models are very important in infrastructuring your own server. So make sure not to skip this class, because if you do, you might miss out on something very important without knowing, and then you might face a bit of hassle later on. So without any further ado, let's move on to our class by moving on to our presentation of our cloud services brief. First off, we have the SaaS, which is known as the software as a service. The definition of SaaS is that it delivers software applications over the internet on a subscription basis, removing the needs for users to install, manage, or maintain the software, as this is a web service. The characteristics of SaaS are first off is the accessibility. It is accessible from any device with an internet connection. It could be your phone, your tablet, your TV, your device, let's say maybe your PC, laptop, anything. It just needs internet connection and that's all. Then we have is managed service. The provider manages the infrastructure, including software updates, security, and also maintenance. So all of these comes with the package, starting off with the infrastructure, where you don't have to write any codes, including the software updates. You don't have to get inside and update it like manually. It's going to update on its own. And even if it's on manual, you can also change it to automatical and also keep it updated on your own. Then it also has the security, which is going to give you without any information breach, and the maintenance of the whole service due to its subscription based. Then we have its subscription based, typically offered on a subscription model, allowing for predictable cost. So it's going to be payable, or let's say you are only going to pay as long as you need to use it and as long as your server needs to use it. Okay. Then let's move on to our next service, or let's say the example of SaaS. Google Workspace. Productivity and collaboration tools, including Gmail, Docs, and also Drives, use SaaS. You've seen about OneDrive. That is also a part of Google and also its own drive. It uses that subscription-based model so that you can use it up to that specific amount of time and that specific amount of storage. Then we have is Microsoft Office 365, which is also a cloud-based suite for Office applications and also services. If you are totally new to Microsoft, which maybe you are not, because most people who are used to devices or maybe even the laptop or PC has used Microsoft at least even once. So you know about its services. Then we have is Salesforce. The customer relationship management, which is also known as the CRM platform, also uses this type of example or this type of services of SaaS, which is subscription based. Then we have is use cases, email and collaboration tool, customer relationship management, and also enterprise resource planning, which is ERP in short. Now let's move on to the next service, which is PaaS, which is also known as Platform as a Service. The definition of PaaS is that it provides a platform that allows developers to build, run, and manage applications without worrying about the underlying infrastructure. This is mostly used, or this is very popular among people who are new to these type of services, because that specific person or that specific, let's say even an industry, does not have to think about the underlying infrastructure, because most of the services are going to be given by the PaaS. So what are the characteristics of PaaS? The development tools. It includes tools for developing, testing, and also deploying application in case of making your own app. So you can create your own app inside of that server or using that service, test it out in that specific DNS or specific server or that environment, and also deploy that application just by using that specific platform. Abstracted infrastructure. The provider manages servers, storage, and networking, enables developers to focus on coding, because the providers manages every servers. So you don't have to think about that specific environment, which is basically a safe environment for actually testing them out. so that the developers can only focus on coding instead of any other stuff, which is used by all of the developers that are on the market right now, or even who are trying to build more. Then we have is scalability, which is a built-in scalability to handle various workloads. It could be low, it could be high, but everything is going to be managed and also organized by the PaaS service. So what are the examples of PaaS service? Google App Engine, which is a platform for building and also deploying applications on Google's infrastructure. So you can see like when you go off the App Store or maybe even some APK files, which are also not on app stores, but you can find them, you can use them. You can see in a couple of cases, let's say a couple of apps are not found on the Play Store or the App Store. So where can they be found? They can be found on specific links and specific environments or specific servers from where you'll be able to download and use them or use it on your platform at the same time. So what basically happens is that you can run those things inside of the Google App Engine and then test them out and then also deploy these applications on Google infrastructure. And also as the example I said, a couple of apps are not found in couple of sites and even Play Store or App Store. What happens is that when it does not meet up that specific security requirements, it cannot be deployed in the Google's infrastructure. So what happens is that it becomes an open source and then you have to download it from a third-party link. Then we have is Microsoft Azure App Services, which is a platform for building and also hosting web application. This is a very popular site and also a very popular app service, which is used by a lot of people and a lot of developers right now. Then we have is Heroku, which is also a cloud platform for building, running, and also operating applications just like you do in Google App Engine. Then we have is the use cases of it. Web and mobile application development, API development and also management, and also application lifecycle management. So these are what it is used for. Then we have is IaaS, which is known as Infrastructure as a Service. The definition of IaaS is that it provides virtualized computing resources over the internet, allowing user to rent virtual machines, storages, and networks on a pay-as-you-go basis, which is a very important and also a very compatible service right now. So what are the characteristics of IaaS? First off comes the scalability. Resources can be scaled up or down based on demand. And also it's going to depend on the storage. If you want to save more storage, make it low. If you want to, or if you have a higher storage, you can scale it up, increase up the size, and then keep it on your storage, and it's going to have the best security there is. Then we have is control. Users have control over the operating system, storage, and also the deployed applications. So thus, in case they have the ownership, they can also remove the application, change the application, make more updates, and also change the storage of that specific system or that app. So you can like already see as an example is that the apps or games or whatever you use on your device. You can see in a couple of times when there is a system update of any specific application or maybe even a game, what happens is that it changes up the size just a bit. Maybe sometimes it increases, sometimes it also decreases. So it depends on the control. If the developers want to reduce the load or reduce the size, they can do it because it has the scalability service. So they have full control over the application, even if it is on or working on the servers as, let's say, a real-time service. Then we have is cost efficiency. It reduces the need for physical hardware and also associated cost. Obviously, you can see a couple of industries, companies and even a lot of people have physical hardwares and associated cost. Because when you have a physical hardware, or let's say even a physical server, it takes up a lot of money to actually build one or actually manage one. Okay. And you also have that, let's say, problematic thought, or maybe let's say even the thought in your mind that what happens if that server gets destroyed, because all of the data inside of that server is going to be destroyed. But when you use IIAS or IaaS, it's going to control everything inside of that web developing software, or maybe even not a software, which is basically a web service. So what are the examples of IaaS? Amazon EC2, which is the Elastic Compute Cloud, which is a virtual server for running application. So obviously you don't want anything which does not work properly to be out in the web. Obviously you have to run it, test it. So for that, you can see Amazon EC2 gives you out that virtual server. Then we have is Google Compute Engine, virtual machines running on Google's infrastructure. So obviously you cannot create a lot of services without using Google Compute Engine. So what happens is that the virtual machine runs on the Google infrastructure and allows you to test it out inside of that. Then we have is Microsoft Azure Virtual Machines, virtual machines for a variety of computing solutions. So obviously, if you want to fix out a couple of problems inside of your app, you can use Microsoft Azure Virtual Engines so that you can fix a variety of computing solutions. So what are the use cases of IaaS? It helps for hosting websites and also applications before even deploying them. Then we have is data storage and also backup. And the last one is disaster recovery solution. Just like I said, if the physical server gets destroyed, you will lose everything or you will lose all the data. But if you're using this web service, you can recover it anytime you want, even if you accidentally remove it or even if it gets destroyed. Then we have is FaaS, which is function as a service. The definition of FaaS is that it allows user to execute code in response to events without provisioning or managing the server. So just like you've seen in my previous class about FaaS, you don't need a specific infrastructure or a whole team to manage it and provision it. You just need FaaS and it will do everything on its own. It's going to execute the code so that every problem is fixed. It is also known as the serverless computing. It does not need a server, but it uses the virtual environment to use specific other, let's say, maybe a runtime or even, let's say, an environment to work on, maybe even Google, Azure, Microsoft, and all of those. Okay. The characteristics of FaaS are that event driven. Functions are triggered by events such as HTTP request, database changes, or file uploads. So let's say you are searching for anything on the Google. You can see sometimes you get a specific result. Sometimes you see there is different result. So what happens is that when any file gets uploaded or the database is changed, it's going to also change inside when you are using FaaS on your own server. No server management. The cloud provider manages the infrastructure, scaling, and resource allocation. It's not going to check out or analyze your storage, but it's going to scale the resources and also allocate it so that it looks very organized and you have your data whenever you need it inside of that specific allocation. Cost efficiency. Users pay only for the execution time and resources consumed by their functions. So you are only going to pay when you are using or just the time when you are using these resources and these services. So what are the examples? AWS Lambda. Run code in response to events such as changes to data in an S3 bucket or updates to a DynamoDB table. Google Cloud Functions. Event-driven functions to run on Google's infrastructure. Microsoft Azure function, on-demand execution of code triggered by events. You can see from three of these is that all of them are run automatically without even having the infrastructure on your own. So everything is going to be executed by the code of command by this specific service. So what are the use cases of this? Real-time data processing, which actually helps you to actually update on real time too. Microservices architecture. It also fixes up the architecture with the allocation and also automation and orchestration of tasks. So everything is automated and also orchestration. So what is the summary of these cloud services? SaaS, which is software as a service, delivers software applications over the internet managed by the provider. So this means you are going to use this service, but you have to manage on your own. Then we have is PaaS, which is platform as a service, provides a platform for developing, testing, and also deploying applications without managing infrastructure. So you can also develop and test out and deploy applications, but you don't have to worry about the infrastructure. You just have to worry and you just have to think about the coding. IaaS, which is infrastructure as a service, offers virtualized computing resources such as virtual machines and storages over the internet. So obviously, if you try to get your own storage when you are trying to build an app or build a service, you're going to, or it's going to take a lot of money because to actually invest in them, it's basically sometimes even life's work. So IaaS has that covered. Then we have is FaaS, which is function as a service. It executes the code in response to events without the need to manage servers, often referred to as a serverless computing. Each service models offers unique advantage and caters to different needs, from simple software usage to complex application development, and also the infrastructure management of your own service or even your own application. So hope you understood everything about this class on how you are going to know or about the brief of these cloud services or these cloud models. Okay? If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. But just make sure you do not skip any part of this class because every part of this lecture or this class is very important before getting into AWS as a career. So thank you for watching this video again. And without any further ado, let's move on to our next class of AWS. Welcome back to our course and a new class of AWS. In this class, I'm going to tell you and show you about the brief you should need to know about cloud deployment models and their uses with its examples. I have prepared a presentation for you guys for you to understand it so that you can understand it properly, even though if you are totally new to it, so that you can understand. And when you want to get into practicals with AWS, you'll be able to implement them. So make sure not to skip any part of this class because everything is going to be very important. So without any further ado, let's move on with our presentation. First off, the public cloud. So what is the definition of a public cloud? A public cloud services or public cloud service is delivered or are delivered over the public internet and shared across multiple organizations. So the connection between different organizations or that link between them is called the public cloud. Well, these services are owned and operated by third-party cloud services providers. So it's not going to be those first-hand, totally trusted operators. So you have to get into third-party cloud services, but obviously as those services have also the data, they are also almost a bit trusted. Okay? Then let's move on to the characteristics of a public cloud. Scalability. You can easily scale up or down based on your specific demand. Obviously, if you want to increase the size and if you want to decrease the size, obviously you'll be able to scale them, but it's going to be depending on the demand. So it could also be on different cost. Then comes cost efficiency. No capital expenditure pay-as-you-go pricing models. So there is no specific pricing for these type of clouds or these type of services. But as these are third-party cloud services, it can be like different from one another. And also it's going to vary from region to region. Accessibility. It is accessible from anywhere with an internet connection. Obviously, this is a public cloud. You just need internet connection and just your device to access them anytime you want to. So what are the examples of a public cloud? First off, AWS or Amazon Web Services. It provides a wide range of cloud services, including compute, which is EC2, and the storage S3 and database RDS. So you can see that when AWS is using a public cloud, it basically uses EC2, S3, and RDS. And these all together completes up the service. Then we have is Microsoft Azure. It offers services such as virtual machines, databases, and also AI tools. Now, there are a couple of AI tools which you will find out when you're getting the service from Microsoft Azure. Then we have is Google Cloud Platform, which is GCP, which provides compute services, which is computer engine, and storage cloud storage, and a big data tool called BigQuery. So just like you can see, when it is used by Amazon, they use EC2, S3, and RDS to complete up the structure, while in Google Cloud Platform or GCP, they use Compute Engine, Cloud Storage, and BigQuery to complete out the infrastructure of this service. So what are the use cases of a public cloud? Startups and SMEs. Leverage the public cloud to avoid upfront infrastructure cost. Obviously, when you're using a public cloud, as there is literally no expense or even some expense, it's like comparatively really low depending or comparatively to other cloud services. Web hosting. Host websites and web application using scalable cloud resources. Development and testing. Quickly spin up and tear down environments for software development and also testing, as the cost is very low or even no cost at all. You'll be able to use it according or to your desired time you need to actually complete the whole thing. Then comes private cloud. What is the definition of a private cloud? A private cloud service are used exclusively by a single organization. The infrastructure may be hosted on premises or by a third-party provider, but it is dedicated to the single organization. So every files are going to be very private. Now, what are the characteristics of a public or a private cloud? Control. Greater control over the environment as it is dedicated to one organization. Now, the environment is going to be depending, or the environment means, let's say, the virtual environment created by that specific organization. Let's say a specific server of that specific organization. That is why a person, or let's say organization or industry have higher control over the databases inside of that server. Security. Enhanced security and privacy, which makes it suitable for sensitive data and regulatory compliances. Most of the organization, industries, factories, all of them mostly are on private cloud or hybrid cloud. It just helps them to keep specific or sensitive data into security and also private, while a public cloud is also used at the same time to keep or actually give out the resources when a user is trying to get the access of it. But it's going to be depending on the boundary which the regulatory makes. Then we have customization. It can be customized to meet specific business needs. So obviously, like let's say even an organization, they're not going to be run on a specific or only one command line, or let's say only one strategy. Obviously, the strategy can change from time to time. So it can also be customized whenever you want to. What are the examples of a private cloud? VMware or vSphere, virtualization platform that enables the creation and management of private clouds. OpenStack, open source platforms for building and also managing the private clouds. Then we have is IBM Cloud Private, which is a platform for developing and managing containerized applications on private infrastructure. So, what are the use cases of a private cloud? Healthcare. Manage sensitive patient data with stringent compliances requirements. Obviously, you don't need every data. Then we have is financial services. Securely handle transactions and customer information. This is also something which you don't want there to be in the public. Then we have is government agencies. Maintain control over sensitive government data and comply with regulatory standards. Then we have is a hybrid cloud. The definition of a hybrid cloud is that it combines public and private clouds, allowing data and applications to be shared between them. This model provides greater flexibility and optimized existing infrastructure, security, and also the compliance. So, what are the characteristics of a hybrid cloud? Flexibility. Seamlessly move workloads between public and also private cloud. Cost efficiency. Optimize cost by running sensitive workloads on private cloud, which is also expensive at certain times and in specific regions, and less sensitive workloads on a public cloud. As these are mostly run by third party, it has lots less cost than having a private cloud. So this is very useful when a person or even an organization is using a hybrid cloud. Scalability. Use public cloud resources to handle the peak demands. So another thing which I'm going to tell you in addition is that public clouds are also those type of clouds which can also maintain a very good performance at a very high traffic. Now, what are the examples of a hybrid cloud? AWS Outpost. Extend AWS infrastructure, services, and tools to on-premise data centers. Microsoft Azure Stack brings Azure cloud services to on-premises environments such as the virtual environment. Google Anthos allows running applications unmodified on existing on-premises hardware or in the public cloud. Now, you might think that if it is on the public cloud, you might have that security breach. So you don't have to think about that because when you're using Google Anthos for running or allowing to run the application unmodified on existing on-premises hardware, it can also be on the public cloud. But most of the things or the sensitive cases will still be on your hardware in the private cloud. Now, what are the use cases of using a hybrid cloud? Disaster recovery. Use public cloud for backups and disaster recovery while running primary operations on private cloud. Well, I've already told you about this in my previous classes, that if you have a hardware or if you have a physical server, well, there could be disaster anytime or even an accident. So make sure while you are running operations, keep a lot of stuff or keep a lot of data in your backup in the public cloud and the other sensitive data inside of your private cloud so that no one can reach it until the regulatory standards. Cloud bursting. Handle overflow traffic by bursting into the public cloud during peak times. Sometimes what happens is that when you are using a private cloud, it cannot work or give you the best performance when it is at its peak times. Let's say when there's high traffic, sometimes private cloud cannot give access to specific amount of users. So make sure to use the hybrid cloud, which will automatically indirect or directly just direct the user into the public cloud. Then we have is regulatory compliance. Keep sensitive data in private cloud while leveraging public cloud for scalability. Make sure to use your private cloud to store in the data, while you're going to leverage and store the other data, which is not that sensitive, inside of the public cloud. Because when you want to scale any specific data inside of the private cloud, you have to think about how much storage you have. And depending on that, you might also have to increase the storage, which will make it a lot more expensive. So make sure to keep a couple of data or even run the examples or even test drive them inside of the public cloud so that you don't lose the extra space which you need inside of your private cloud. Then we have is multi-cloud. So what is the definition of a multi-cloud? The definition is that it refers to the use of multiple cloud services from different providers to avoid dependency on a single vendor and to optimize performance and also cost. What is the characteristics of a multi-cloud? Vendor flexibility. Avoid vendor lock-in by using multiple cloud providers. Now, in this era or in this age, there are a couple of vendors which also locks up at certain times, or even sometimes these vendors might even be a couple of scams. So you have to make sure that you don't build in that specific type of dependency. Obviously, the most trustable and liable vendors are going to be very expensive because they are going to give you the best security and also the best storage which you can get in the market. So when you are using multi-cloud or you're getting cloud services from specific or even a lot of vendors, what happens is that you don't have to depend on one cloud or one cloud provider. So make sure to also experience the other vendors which you have in your locality or even the best ones in your region so that you can experience them and then select the ones which you want to use. Then we have is optimized performance. Choose the best services from different providers based on performance and also the cost. Just like I said, the expense is going to depend and vary from time to time, vendor to vendor, and also region to region. So make sure to experience the ones which you have close by and also try out the ones which are best on the performance and also the cost. Redundancy and resilience. Improve resilience by distributing workloads across multiple clouds. Now, just like I said, when you are using a multi-cloud service or getting services from multiple cloud vendors, what happens is that you are obviously going to use, let's say, a private cloud. But what happens is that if you want the best performance out of private clouds, you cannot depend on only one vendor. So when you actually compliance them or just add them all together and work them, or let's say intertwine them all together and then keep it on the server as the service, what happens is that even if there's a lot of traffic, it's just going to redirect to the one where it has less traffic and is going to give you the best performance. And a lot of organizations follow this method so that they get the best security and also the best performance out of the other ones or the newer ones who use one specific vendor. Examples. Using AWS and Azure. Deploying web services on AWS using an Azure for machine learning tool. So, using AWS in Azure can help you to deploy the web services on AWS while using Azure for only machine learning tools. Combining GCP and also IBM Cloud. Using GCP for big data processing and IBM Cloud for blockchain services. Mix of SaaS providers. Using Salesforce for CRM Office 365 for productivity and AWS for infrastructure. So all of these things together can actually give you out the best services when you actually compile them all together. So what are the use cases of this specific cloud service? Data sovereignty. Keep data in specific regions as required by regulations by using different cloud providers. Now, another thing you can try out is that you don't have to use all the data inside of your specific region. Well, there could be sometimes some regulations or laws which is going to force you to not keep that data inside of that region. For that, you should also try different regions for storing specific data inside of a specific cloud provider. Best of breed solutions. Select the best cloud services for specific needs from different providers. Risk management. Mitigate risk by diversifying cloud providers to prevent single points of failures so that when you actually come up to an error or a failure, you can just change up to another service. Now, what is the conclusion? Each cloud deployment model offers unique advantages suited to different businesses' needs. So, there are a couple of them, and I'm going to give you out the summary of these 4 cloud services, which we've already read about in these classes. Public cloud, which is ideal for scalability and also cost efficiency. Private cloud is the best for control, security, and also customizations in real time. Hybrid cloud provides flexibility and optimal resource utilization. And multi-cloud offers vendor flexibility and optimized performance in all regions. Choosing the right deployment model depends on factors like business, goals, compliance requirements, budget, and also technical capabilities. So hope you understood everything about this class on these cloud services and also a couple of vendors which I've shown you in this class. Make sure not to skip anything in my next classes too, and thank you for watching this video up till the very end. If you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to a new class of AWS. In this class, we're going to learn about the common myths about cloud computing. I have done a bit of research on common myths about the cloud computing, so I will give you the best decisions, and also I'm going to clear out a couple of things which you need to know, and you need to know about the best ideas about them. So I've prepared a presentation so that it clears out everything. So without any further ado, let's move on with our presentation with our first myth. Cloud is less secure than on-premises solutions. While in reality, I have prepared a couple of points. Security measures. Leading cloud providers implement advanced security measurements, including encryption, intrusion detection system, and also regular security audits. So this has already given you idea that cloud providers are also very safe nowadays. Shared responsibility models. There are a couple of shared responsibility models. Let's say Canva or maybe even Microsoft. You can see that you'll be able to work at the same time but you can only give them, or let's say the owner or the author can only give access to specific people. And those are also of a cloud service. Security is a shared responsibility between the cloud providers and the customer. Providers secure the infrastructure while customers secure their data and also applications. Certification. Cloud providers often comply with industry standards and certification such as ISO 27701 or HIPAA and also GDPR. So, this will also clear you out that cloud service is also very responsible right now. The example is AWS provides a comprehensive set of security tools and compliances certifications, often surpassing what individual companies can achieve on their own. So, these type of cloud services are very safe. Myth 2. So, the second myth is that cloud is always cheaper. Let's see what the reality is. First off comes cost management. While the cloud can reduce capital expenditure, costs can escalate without proper management due to pay-as-you-go pricing models. So just like I said in this class and also previous classes, that it can differ from time to time, region to region, and vendor to vendor. Hidden cost. Expenses related to data transfer, storage, and additional services can also add up. So you might see that you are only paying for the storage, but what about the other services? What about the other expenses related to data transfer? All of those will add up, which will also turn up to be a lot more than what you expect it to be. Optimization. Cost savings are maximized with efficient resources or resource management and by leveraging reserved instances and auto-scaling features. So what are the examples of why cloud is always cheaper or what people think about it? A company might or may find cloud storage cheaper initially, but frequent data transfer costs and also underutilized resources can lead to higher expenses over time. So when you are actually, let's say, making it more optimized or optimizing your services, it will obviously add up to more expenses. Now let's see what myth 3 is. Migrating to the cloud is too complex. Let's see what the reality holds. Tools and services. Cloud providers offer a variety of tools and services to simplify migration, such as AWS Migration Hub and also Azure Migrate. When you are using these type of services for migrating to the cloud, it's not that complex. Expert assistance. Professional services and cloud consulting firms can assist with planning and executing a migrating service or migration strategy. Now, if you go off to, let's say, an expert assistance or maybe a professional service vendor, they might also give you or assist you with the planning and also how to execute that migration strategy. Well, if it does not meet up your criteria, you can obviously change it anytime you want to. But obviously make sure that your strategy should come in handy in times of need. Incremental approach. Companies can adopt a phased migration approach, moving one application or services at a time to reduce complexity and also reach. Obviously, when you are actually, let's say, migrating to the cloud, and what people think is that it's complex. Well, sometimes it is. So obviously, if you go off like transferring your data inside of your cloud at the peak time or the highest using time, or let's say higher traffic, obviously it's going to be a bit more complex than using it at the time of low traffic. And it also has less risk. Example, using AWS Migration Hub, a company can track the progress of their migration across multiple AWS services and also automate much of the process inside of it, which is going to be automated. So make sure to turn these things and be clear and vivid before getting assistance. Myth 4. Cloud means losing control over data, which is the worst, or let's say this is the most rumors, let's say, spread by most people, because people who do not have any experience over cloud, they do not know how you can also store data at a very secretive phase. While in reality, we're going to check it out. Data management. Cloud services offer extensive control and tools to manage data, including data residency options, access controls, and also encryption. So not only just security, it's going to give you the best security to save and secure your data. Visibility and also monitoring. Cloud providers offer robust monitoring and also management tools that provide visibility into data usage and also your performance. Compliance. Cloud providers comply with data protection regulations and offer tools to help customers meet compliance requirements. So what is the example of it? AWS provides tools like AWS CloudTrail and AWS Config to give customers control and visibility over their resources and their data. Now let's move on to our next one, which is myth 5. Only large enterprises benefit from cloud computing. While in reality, let's check them out. Scalability. The cloud is scalable, making it suitable for businesses of all sizes. Small and medium-sized enterprises or SMEs can scale resources up or down based on demand. So you do not have to think like you will not be able to scale them anytime you want to. While when you're using the cloud service, you'll be able to get those required type of services, which will obviously help you to scale it in the time of need. Cost effectiveness. SMEs can avoid large upfront capital investments in hardware by leveraging cloud resources on a pay-as-you-go basis. So you do not have to think that if you want to get into cloud services, you're going to need hardware or physical servers. Obviously, no. If you want to get into those services, such as pay-as-you-go basis, obviously you will get the best service out of them too. Innovation. Cloud services provide access to advanced technologies such as AI, ML, and big data analytics, which can drive innovation in smaller businesses too. And obviously, you'll be able to get benefit from them too at the same time, how large enterprises get their benefits. Let's say, as an example, startups often use cloud services to quickly deploy applications without the need for significant initial capital investment, allowing them to scale as they grow. So this is also very flexible. So if you want to scale your resources anytime you want in later use, or maybe let's say in future cases, you'll be able to change them in real time according to what service you take. Myth 6. Everything must be migrated to the cloud. Well, this is absurd. While in reality, let's check the points. Hybrid solutions. Many organizations use a hybrid cloud approach, maintaining certain workloads on premises while migrating others to the cloud. So obviously you are not going to need certain workloads when you don't have to take it. You can just directly give it out to the cloud services so that they can migrate it to the cloud and save them. Assessment. Companies should assess which applications and workloads benefit most from cloud migration, considering factors like performance, cost, and regulatory requirements. Tailored strategy. A tailored Cloud strategy allows businesses to choose the best environment for each workload. So obviously there are a lot of services which you will get when you are directly using the services of AWS. Example, a financial service company may choose to keep sensitive transaction process on premises while using the cloud for less sensitive tasks like data analysis and all. Myth 7. Cloud automatically provides high availability and disaster recovery. While in reality, let's check out the points. Planning. High availability and disaster recovery require proper planning and architecture design. So obviously, if you create something which does not have the data pool to recover the data in times of need, obviously, if you don't have those services, you will not be able to recover them. Okay? And also high availability. It also comes at certain times from certain vendors. Built-in tools. Cloud provides offer tools to help achieve these goals, but customers must configure and manage them in times of need. Responsibility. Organizations need to implement best practices and use the available tools to ensure high availability and disaster recovery. The example of it is AWS offers services like Amazon RDS, multi-AZ deployment for high availability, and AWS backup for disaster recovery. But customers must set them up correctly, because if those are not infrastructured perfectly or step by step, it's not going to be there and you will not be able to recover your data in times of need. So what are the conclusions? Understanding the realities of cloud computing helps organizations make informed decisions about their cloud strategies. Dispelling these myths can lead to more effective use of cloud resources, maximizing benefits while minimizing risks and also cost. Thank you for watching this video up till the very end and hope you understood about everything in this class. If you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to another class of AWS. In this class, we're going to learn about the major cloud service providers with examples. I'm going to give you a presentation, or I'm going to show you a presentation where it will have a vivid and also a clear major cloud services and also with its example. So let's move on to our presentation, starting with our first service, which is AWS, which is Amazon Web Services. The overview of Amazon Web Service is that it is a comprehensive and widely adopted cloud platform, offering over 200 fully featured services from data centers globally. It is known for its robust infrastructure and a broad range of service. So what are the key services of AWS? Compute. Amazon EC2, or which is known as Elastic Compute Cloud. Well, I've already given you a brief about these services at the beginning of this course. If you didn't check them out properly about how it works and how it functions, go check out those videos again, and it will give you a clear idea about what it is. Then we have is storage. For storage, AWS uses Amazon S3, which is simple storage service. Then we have is for databases. For databases, Amazon uses Amazon RDS, or which is also known as Relational Database Service. Then we have is AI and also ML working and functioning in AWS. For that, Amazon uses Amazon SageMaker. For networking, Amazon uses Amazon VPC, or which is also known as Virtual Private Cloud. As an example for AWS, Netflix. It uses AWS for nearly all of its computing and storage needs, including databases, analytics, recommendation engine, video transcoding, and also more. Then we have is Microsoft Azure. Azure is a cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft managed data centers. It supports various programming languages, tools, and frameworks. What are the key services of Microsoft Azure? Compute. Azure Virtual Machines. For storage, Azure Blob Storage. For database, Azure SQL Database. For AI and ML, Azure Machine Learning. And for networking, it uses Azure Virtual Network. As an example of Microsoft Azure, Adobe. Adobe uses Azure to run its cloud-based Creative Cloud Documents, Cloud, and Experience Cloud services, benefiting from Azure scalability and machine learning capabilities at the same time. 3. Google Cloud Platform, or which is also known as GCP. Overview. GCP is a suite of cloud computing service offered by Google, providing a wide range of hosted services for compute, storage, and application development that run on Google hardware. So what are the key services of GCP or Google Cloud Platform? Compute. Google Compute Engine is used for computing. Google Cloud Storage is used by Google for its storage. For databases, Google uses Google Cloud SQL. For AI and ML, it uses Google AI Platform. And for networking, it uses Google Virtual Private Cloud, or also known as GVPC. As an example, Spotify. It leverages GCP for its storage, data processing, and machine learning needs, enabling it to deliver music streaming services efficiently to millions of users without any delay. Then we have is IBM Cloud. Let's see what the overview of IBM Cloud is. IBM Cloud provides a suite of cloud computing services for businesses, including IaaS, SaaS, and PaaS, while FaaS does not use IBM Cloud. It integrates well with existing its infrastructure, making it a choice for many enterprises, starting from medium to high. You can also use, or let's say beginners can also use IBM Cloud, but I would suggest those who are beginners try using GCP. So let's see what the key services of IBM Clouds are. Compute. IBM Cloud Virtual Servers. For storage, it uses IBM Cloud Object Storage. For database, it uses IBM DBZ on cloud. For AI and ML, it uses IBM Watson. And for networking, it uses IBM Cloud Internet Services. So what is the example of IBM Cloud? American Airlines. It uses IBM Cloud to enhance its user service capabilities and streamline operations through AI and machine learning solutions provided by IBM Watson. So, AI and ML of most of these cloud services offer you real-time changes, so you don't have to worry about shutting down your service or shutting down your application for the update. Then we have is Oracle Cloud. Let's see what the overview of it is. Oracle Cloud offers a comprehensive and fully integrated stack of cloud applications and platform services. It is known for its strong database services and enterprise solutions. So what is the key service of Oracle Cloud? For compute, it uses Oracle Cloud Infrastructure, OCI Compute. Then we have for storage, it uses Oracle Cloud Infrastructure Object Storage. For databases, it uses Oracle Autonomous Database. For AI and ML, it uses Oracle AI Services. And for networking, it uses Oracle Cloud Infrastructure and networking at the same time. As an example of Oracle Cloud, let's see which app uses it. Let's say Zoom. Zoom relies on Oracle Cloud Infrastructure to support its rapidly growing user base, benefiting from Oracle's robust performance and reliability. Then we have is Alibaba Cloud. Let's see what the overview of Alibaba Cloud is. Alibaba Cloud, also used or known as Aliyun, is a subsidiary of Alibaba Group, providing a comprehensive suite of global cloud computing services to provide or power both international customers, online businesses, and Alibaba's own e-commerce ecosystem. Let's see what the key services of Alibaba Cloud is. For compute, it uses Elastic Compute Service, which is also known as ECS in short. For storage, it uses Object Storage Service, or OSS in short. For databases, it uses Apsara BD for RDS. For AI and ML, Alibaba Cloud Machine Learning Platform for AI is used. And for networking, it uses Alibaba Cloud Virtual Private Cloud. So when you see that any of these organizations using these type of private clouds, obviously it means it is using or investing a huge amount. An example, AirAsia uses Alibaba Cloud. AirAsia uses Alibaba Cloud to support its digital transformation, improving customer experience and operational efficiency through data analytics and also AI at the same time. So let's move on to our conclusion. Each of these cloud service providers offer a unique set of services and strength. They differ from time to time, catering to different business needs. Choosing the right provider depends on specific requirements such as scalability, cost, performance, security, and the range of services needed. So you can try each and every one of them, but make sure to select the one which you are trying to get the service for and what your application is developed for. Because if you just choose any one of them, and even if you choose a cloud service from any one of these clouds, yet if you see that the cost is low, but it will not be able to actually amplify your own developed AI or even your own developed application, you will not be able to get it or get that service unless those services are provided by that cloud provider. So make sure to experiment and do your researches on these cloud providers and select the one which your application needs. Thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion over any of these things or any part of this classes, feel free to ask me anytime. I'm always there to help you out. Just make sure not to skip any part of these classes, even though these are mostly theoretical based and it can be boring at certain times. So without any further ado, let's move on to our next class of AWS. Welcome back to another class of AWS. In this class, I'm going to give you a brief and clear, vivid idea about the careers in AWS. And for that, another presentation for you so that you can understand it very easily. Let's move on to our project, or let's move on with our presentation. Let's see what the overview holds. A career in AWS can be highly rewarding, offering various roles across different skill level and also specialties. Here's a brief overview of some common AWS-related career paths. First one is Cloud Architect. Let's see what the role is. Design and implement scalable, reliable, and secure AWS solution for a specific organization. And what is the skill? deep knowledge of AWS services, cloud architecture, best practices, networking, security, and also cost management. And what are the certifications? AWS Certified Solutions Architect, which is can be associate and even professional. The next one is DevOps Engineer. Let's see what the role is. Automate and manage infrastructure on AWS, facilitating continuous integration and continuous deployment, which is also known as CI or CD in process. So what are the skills you should need to know for being or for choosing this career? AWS services, automation tools, example like Jenkins or Terraform, scripting languages, which is an example Python or maybe Bash, and DevOps methodologies. What are the certifications of DevOps engineering? AWS certified DevOps engineer, and you have to be professional in it. Then we have is cloud developer. Let's see what the role of a cloud developer is. Develop and maintain applications and services using AWS tools and also services. For that, you need the skills of a programming language, in example Python, Java, Node.js, and so more. AWS SDKs, serverless architecture, and microservices. The certification of cloud developer is AWS Certified Developer, and you can be associate for that. The next one is Cloud Security Specialist. The role of a cloud security specialist is that to ensure the security of AWS infrastructure and applications by implementing best practices and compliances measures. What are the skills? AWS Security Services, in example IAM, KMS, or even Guardity. Security best practices, compliance frameworks, an example GDPR and HIPAA. The certifications of a cloud security specialist is AWS Certified Security Specialist. You can be either an associate or even a professional. Then we have is a data engineer. The role of a data engineer is to design and manage data pipelines, data lakes, and data warehouse on AWS. The skills you need to be a data engineer is AWS Data Services, an example, Redshift, RDS, Glue, etc. Then we have is ETL processes, data modeling, and also SQL. If you have no idea about SQL, then you can go check out a couple of videos and also learn a bit of MySQL and a bit of PHP, which will give you better ideas on SQL and data analysis. Then we have is certifications for a data engineer. AWS Certified Data Analytics Specialist. Then is a machine learning engineer. The role of this engineering is to build and deploy machine learning models on AWS using services like SageMaker. What are the skills you should need or require? Machine learning algorithms, AWS Machine Learning Services, Python, R, and data science. What are the certifications? AWS Certified Machine Learning, and you have to be a specialty. What are the benefits of an AWS career? High demand. Cloud computing skills, particularly with AWS, are in high demand across industries. Competitive salaries. AWS professionals often command high salaries due to the specialized skill required. Career growth. Opportunities for advancement and specializations in various areas of cloud computing. Certifications. AWS offers a range of certifications that validate your skills and enhance your career prospects. So starting your AWS career, and how will you be able to do that? Learn the basics. Gain a solid understanding of AWS fundamentals through online courses, tutorials, and hands-on practice. Get certified. Pursue AWS certifications to validate your skills and also knowledge. Hands-on experience. Work on real-world projects either through your current job or by participating in open source projects or hackathons. Networking. Join AWS user groups, attend conferences, and participate in online forums to connect with other professionals in that specific field. Thank you for watching this video up till the very end, and hope you understood about everything in this class. If you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you. But one thing you have to make sure is that you do not skip any part of any of the classes, because these theoretical classes are going to be very helpful to clear out a couple of ideas, clear and vivid at the same time. So, without any further ado, let's move on to our next class of AWS. Welcome back to another class of AWS. In this class, I'm going to give you a clear and vivid idea and also a brief idea about AWS role-based certifications. For this class, I have also created another presentation for you guys so that it gives you out a clear idea. And also you don't have to worry about these lectures or these presentations, because by the end of this course, I'm going to be giving out this whole project or this whole presentation with the resource file. So whenever you want to read it, you can just open up the resource folder and use it anytime you want to. So without any further ado, let's move on to our class. But if you have no idea about the role-based certification, make sure to check out the previous class properly, and it will give you a bit more idea about what we are going to reveal and what we are going to talk about in this class. Let's see the overview of AWS offers. AWS offers a range of role-based certifications designed to validate your skills and knowledge for specific job roles in cloud computing. Here's a summary of the main AWS certification categorized by role. First one is a cloud practitioner. The role of a cloud practitioner is foundational level for individuals seeking a basic understanding of AWS, in case or an example, this class. Certification. AWS Certified Cloud Practitioner. Focus of this cloud practitioner is that AWS cloud concepts, basic AWS services, and basic AWS pricing and support. And what is it ideal for? Newcomers to cloud computing and AWS, non-technical roles needing a basic understanding of AWS. 2. Architect. The role of an architect is design and implement scalable and reliable AWS architectures. Certification of an architect is AWS Certified Solution Architect. Associates focus. Designing resilient, high-performancing, secure, and cost-effective architectures. And what is it ideal for? Individual with experience in designing cloud architectures and also applications. AWS Certified Solution Architect. Professionals. Focus is advanced skill in designing complex solutions, including multi-account architectures and hybrid cloud environments. And what is it ideal for? It is ideal for experienced architects who design complex AWS solutions. Developer. The role of a developer is to develop and maintain applications on AWS. The certification of a developer is AWS Certified Developer as an associate. The focus of that developer is development and deployment of applications on AWS, including understanding of core AWS services, AWS SDKs, and best practices for building secure and scalable applications. What is it ideal for? It is ideal for developers who create and manage applications on AWS. DevOps. The role of a DevOps is to automate and manage AWS infrastructure and deployment pipelines. The certification of a DevOps is AWS Certified DevOps Engineer as a professional. The focus of a DevOps is to implement and manage continuous integration and continuous delivery, which is CI and CD pipelines, automation, and operational monitoring. It is ideal for a DevOps professional with experience in managing AWS environments and deploying applications online. 5 is security. The role of security is to manage and implement security measurements on AWS databases and data pools. The certification of a security is AWS Certified Security as a specialty. The focus of security is advanced security topics, including data protection, access management, and monitoring security compliance. It is ideal for security professionals responsible for managing security and compliance in AWS environments. 6 is data analytics. The role of a data analytics is design and manage data analytics solutions using AWS. The certification of analytics is AWS Certified Data Analytics as a specialty. The focus of this is data collection, storage, and processing, data visualization, and data analysis. It is ideal for a data engineer, data analyst, and data scientist working with AWS data and analytic tools. Machine learning, or the DevOps. Building and deploy machine learning models using AWS services is its role. The certification of machine learning is AWS Certified Machine Learning Specialty. The focus of this is machine learning algorithms, building and deploying models, and using AWS machine learning services like SageMaker. It is ideal for machine learning engineers and data scientists working with machine learning on AWS. And then we have is networking. The role of it is design and implement networking solution using AWS. The certification of this is AWS Certified Advanced Networking as a specialty. The focus of networking is designing and implementing AWS networking solutions, including VPC design, hybrid cloud architectures, and network security. It is ideal for network engineers and architects specializing in AWS networking solutions. So what is the summary? AWS certifications are structured to validate your skill and knowledge for specific roles in cloud computing. They range from foundational certifications for newcomers to advanced certification for experienced professionals. Obtaining these certifications can enhance your career prospect and validate your expertise in various AWS roles. If you want to change your role anytime, you can do that. But obviously, you're going to need a lot of experience in those specific roles. So thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. And make sure not to skip any part of any of these classes because these theories are going to be very important when you go into practical use and even you want to seek for attention of help from any of the assistance offered by any vendors. So without any further ado, let's move on to our next class of AWS. Welcome to another class of AWS course. In this course, I have given you a clear and vivid idea about the career in AWS and also the role-based certifications which you can get and also the skills which you need to gain those achievements. In this class, I'm also going to give you a whole brief and clear, vivid idea about the AWS certification. I have created this presentation for you guys so that you can understand it properly. So let's check what the overview of it is. AWS or Amazon Web Services certifications are credentials that validate cloud expertise to help professionals highlight in-demand skills and organizations build effectiveness. Innovative teams for cloud innovatives are initiatives using AWS. Here's a brief overview. AWS certification categories. The first one is the foundational one, which is AWS Certified Cloud Practitioner. For individuals who want to gain a high-level understanding of AWS Cloud, including its key services and their use cases, billing and pricing models, and security concept. So for these cases, you have to be foundational, and that is the certification you want to look for. Then comes the associate part. Now there are 3 points which I'm going to describe right now. AWS Certified Solutions Architect. Associate. Associates validate the ability to design and deploy well-architected solutions on AWS that meet customer requirements. So, these AWS Certified Solutions Architects work on well-structured architectures of the service and also work with the data pool. Then comes AWS Certified Developer. They are also associates. These associates focus on the skills necessary to develop and maintain the applications on AWS. So most of the developing type of works, such as coding, languages, and all, they do all of those works. Then we have is AWS Certified SysOps Administrator, also associate. These associate for system administrators in cloud operation roles to validate technical skills in deployment, management, and operations on AWS. So, when you want to actually deploy an application or you want to deploy a service, the management and also operations on bug fixes and a lot of things, or maybe a lot of processes, changes, everything are done by SysOps administrator and also managed by them at the same time. Then comes out are the professionals. AWS Certified Solutions Architect, and they are professionals. These professionals are advanced skills in designing distributed system and applications on the AWS platform to work in real time and also on the cloud service. So let's say there is an update, and whom does it go through? First off, they go through AWS Certified Solutions Architect. If there is any bug, they also fix it up and also distributes it inside of that cloud service or in the cloud server. Then we have is AWS Certified DevOps Engineer. They are also professionals. For professionals with expertise in provisioning, operating, and managing distributed application system directly inside of the AWS server. Now we have is the specialty. And now there are a lot of roles which you will find out comparatively to the other ones. First one we have is AWS Certified Advanced Networking Specialty. These specialty people or those operators or even administrators validates skill to design and implement AWS and hybrid IT network architectures at scale. Then we have is AWS certified big data. They are also specialty. For individuals with expertise in using AWS data lakes and analytics service to derive value from data. Now, they could be also models, but obviously it goes through DevOps and also programmers so that these models can be used. And also, AWS certified big data pools are used. Then we have is AWS certified security branch, also specialty. They validate advanced skills in securing the AWS platform from any security or breaches. Then we have is AWS certified machine learning. They're also for specialty. For individuals with expertise in building, training, tuning, and deploying machine learning models on the AWS server. And the last one we have is AWS Certified Database. They're also for specialty. For professionals with expertise in database design, migration, deployment, and management on AWS. So now you can see after the whole thing, or comparatively to the other ones, you can see that each and every one of these roles complement each other. Without one of them, the other cannot work because they go through step-by-step process. Because if you do not follow these steps, or if it does not go through that specific service, it will not be secured at the end. So, what are the benefits of AWS certification? Career advancement. Recognition of cloud expertise can lead to new job opportunities, promotions, and also higher salaries. Now, you might think that the salary is kind of low, but it's not. People who work on these cloud or these cloud services, they get really good job opportunities. They also get promoted very fast and also get higher salaries. Skills validation. Certification provides a tangible measure of your technical abilities and also expertise, which is very important. Industry recognition. AWS certifications are highly regarded and recognized by the IT industry. So obviously there is really less chance and low chance of security breaches and also camouflages and also wrong ideas and wrong data. Continuous learning. Preparing for certification exams encourages a deeper understanding of AWS services and also the best practices. So, what should you be doing for preparing for AWS certification? AWS training and certification. It offers a range of resources, including instructor LED training, self-packed labs, and also exam guides. Then we have is AWS white papers and FAQs. Reading these documents can provide valuable insights into AWS best practices and also services. Well, in this class, I cannot give you the best practices and also the valuable insights. You will only be able to get them when you are trying to get the service out of them and when you are trying to sit for these certification exams, practice exams. These help you get a feel for the type of questions that will be on the specific exam. Hands-on experience. Practical experience with AWS services is crucial for understanding how to implement and also manage them effectively. So obviously, if you have no idea about how these services work, how it is benefactor, or let's say how it is advantageous in which cases and which phases, you have to understand it. Because if you don't, you will not be able to imply and also implicate it in the time you need to use it. And also, these questions are also going to be on the exams of AWS certification. So you have to know all of these things before you sit for an exam and when you're trying to know more and you're trying to get a certificate from these AWS cloud services or IT industries. So AWS certifications are a valuable asset for IT professionals looking to demonstrate their expertise in cloud computing and for organizations looking to ensure their team have the skills necessary to leverage AWS effectively. Thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. You just have to make sure that you do not skip any part of these classes because every part of it is going to be very important. So without any further ado, let's move on to our next class of AWS. Welcome to a new class of AWS course. In this class, I'm going to give you a brief, clear, and vivid idea about AWS global infrastructure. Till this class, I've given you ideas about the certification, roles, services, how those work, and also examples. But we need to now know a bit more about the infrastructure of how these services function and how it is made and architected. So make sure not to skip any part of this class because this is going to be very important because in a couple of classes, we're going to start our practical lessons. So without any further ado, let's move on with our presentation. Let's check out what the overview of it is. AWS, or Amazon Web Services, global infrastructure is designed to provide a highly scalable, reliable, and secure platform that enables customers to deploy applications and services worldwide. Here is a brief overview. Key components of AWS global infrastructure. Regions. AWS regions are geographic locations worldwide where AWS clusters data centers. Each region contains multiple isolated and physically separate availability zones. Now, how are you going to get this service worldwide? Obviously, if this service only has one center or really less centers in specific continents or even in specific countries, it is going to take really a huge amount of space or storage to save them and also function properly with the best performance in times of need. So to reduce the workload and also the traffic, it is also in specific regions with multiple data centers and data pools. It could also be in virtual isolated places and also physically separated availability zones, which also causes the performance to boost up in all regions. Examples of AWS regions include US East, which is north of Virginia, EU, which is Europe, which is in Frankfurt, Asia Pacific, such as Tokyo, Singapore, Mumbai, and etc. Regions are designated to provide redundancy, data sovereignty, and low latency connection to local users. Obviously, if you have a server, maybe a country close to you, let's say I'm working on a software and I want to get the best performance out of it. But in my specific region, I do not have any data center or any specific server for that application. So when I try to take the service from that specific data center, it's going to be a hassle, or it's not going to be as fast as the people who get the service from where or the region where the data center is. So regions are designated to provide the redundancy and also reduce the latency of data when people are trying to get from it. Availability zones, or AZS. An AZ or AZ is one or more discrete data centers where redundant power, networking, and connectivity housed in separate facilities. Now, these facilities can be placed in separate places. It could be different buildings, or it can be in a specific building, or even in a specific area. Each AZ is isolated but connected with low latency links to other AZs in the same region, enabling high availability and fault tolerance. These AZs also work in virtual environments and also in physical hardwares too. But as these are isolated, most of them are isolated and very less in physical hardwares, they are also spread amongst like specific regions, even in specific areas and multiple of them. So by having these lot of places or lot of these data centers, it enables high availability and also boosts up the performance and is also used to optimize its performance. Deploying applications across multiple AZs ensures resilience against data center failures. So obviously, if you put any specific data only in a specific data center, obviously, if you are trying to get that specific data from that specific data center, but you are very far from that data center, it's going to be a hassle and it's going to take a lot of time to get that specific data and also that specific resource. So having multiple of data centers and also deploying the applications across multiple AZs ensure the resilience and sometimes even, let's say, when one data center goes down, they have to make sure, or the vendors have to make sure that they don't lose all of that data. So these data are separated and also cloned in a lot of these AZs so that data can be recovered anytime they want to. Edge locations. Edge locations are sites that AWS uses to cache copies of content closer to end users, reducing latency and improving the performance. They are part of the AWS Content Delivery Network, which is also known as CDN, Amazon CloudFront. Edge location facilitate fast delivery of static and also dynamic web content, video streaming, and also other content delivery services, such as YouTube, Netflix, and all. Now comes the local zones. AWS local zones are an extension of an AWS region that places compute storage, database, and other selected services closer to large population industry and its centers, or IT centers. They enable applications that require single-digit millisecond latency to end users. Wavelength zones. AWS wavelength zones bring AWS services to the edge of the 5G networking, minimizing latency and network hops required to connect to an application hosted on AWS. If the application of networking is not hosted on AWS, the cloud is not going to function properly and it's not going to work with the required or on the best service given or which is available right now. These zones are embedded within the telecommunication providers, data centers, at the edge of the 5G network. Benefits of AWS Global Infrastructure: high availability and fault tolerance. The distributed nature of AWS regions and AZs ensure that application can remain available and performant even in the face of infrastructure failures. So even if one data center goes down, and even if the infrastructure fails or even gives you an error, it should make sure, or the people or the developer makes sure that the application or the service does not crash. Scalability and elasticity. AWS's global infrastructure supports dynamic scaling of resources to meet fluctuating demands without compromising the performance. So even if the developers or even the managers try to change anything or even configure anything, it should make sure that it does not compromise the performance, because most of the performance depends on the providers and also the network specialist. Low latency and high performance. By using a globally distributed network of regions, AZs, and edge locations, AWS reduces latency and enhances the user experience. Security and compliance. AWS infrastructure is designed and managed in accordance with security best practices and various compliance standards. An example, ISO 2701, SOC 123, and also GDPR. Global reach. With a presence in multiple geographic locations, AWS allows businesses to deploy applications closer to their customers worldwide, ensuring faster response time and a better user experience. Using AWS global infrastructure. Disaster recovery is the first thing. By using multiple regions or multiple AZs, customers can implement robust disaster recovery solutions. Data residency. Customers can choose region based on data residency requirements to comply with local laws and also regulation. In a couple of regions, you will not be able to store the specific amount of data or that specific data. For that, customers can also choose regions closer to them, but not in the region where it is going to be a problem. But obviously, these providers are also going to assist you with storing them and comply it with the local laws and also the regulations. Latency optimization. Deploying applications. So, AWS's global infrastructure is fundamental to delivering scalable, resilient, and secure cloud services to customers around the world. So, hope you understood everything about this class. But if you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you. And just like I said in my previous classes, that you are going to get all of these presentations in my resource folder with this course, so you don't have to worry about, losing any of these lectures or these theories. You can check them out anytime you want to just by opening up the resource folder, which you will be able to download. So, thank you again for watching this video, and without any further ado, let's move on to our next class of AWS. Welcome to another class of AWS. In this class, I'm going to give you a brief description and also examples of AWS core service domains. Without these domains, obviously, the cloud services will not work properly. So I have prepared a presentation for you so that you get a clear and vivid idea about them. So, without any further ado, let's move on to our presentations. Before that, we have to check out what the overview of a domain or AWS domain is. AWS or Amazon Web Services offer a wide range of cloud service organized into several core service domains. These domains cover various aspects of cloud computing, enabling business to build, deploy, and manage applications efficiently. Here's a brief overview of the primary AWS core service domains. First one is compute. Amazon EC2 or Elastic Compute Cloud provides resizable compute capacity in the cloud. So obviously, when you are taking or any organization is taking that specific cloud service, it needs that service or that facility that it can be resizable inside the cloud. And everything is done inside of this domain with the service of Amazon EC2. Users can run virtual servers instances on demand. You will also be able to create yourself a personal or a private virtual environment to test out the applications before deployment. AWS Lambda. It is a serverless compute service that runs code in response to events and automatically manages the compute resources. It also takes the facility or the service of data pools, but it does not need any specific server to compute the service to the users. Then we have is Amazon ECS, which is also known as Elastic Container Service, and Amazon EKS, which is known as Elastic Kubernetes Service. It is used or managed service for running and scaling containerized application. Well, if you've used your device properly, and you can see that just by using a couple of applications such as WinRAR, you can condense or compress any specific file. So you can also do the same thing when you have any file or data containerized, such as an application inside of the server or the domain. You'll be able to manage the services and also run them, scale them, develop, update, bug fix, all of them just by using these services. Amazon Lightsail. It is a simplified virtual private server, which is also known as VPS. It offers small applications and also simple workloads. It cannot take a higher workload or a big workload because this is just a virtual private server only for that specific user who wants to use it on demand. The next one is about storage. Amazon S3, or which is known as Simple Storage Service by Amazon. It is a scalable object storage service with high availability and durability. If you've read or if you've seen my previous classes, well, you already know that couple of AZs are going to be available in your region. And they can also be hardware, physical hardware, or also non-physical ones. So, Amazon S3 actually helps to scale the object storage service with high availability and also durability. That means you'll be able to get your data from anywhere in the world and also be risk-free of data breach. Amazon EBS, or which is known as Elastic Block Store. It provides block storage volumes for use with Amazon EC2 instances. When you will be able, or when you are only using Amazon EC2 instances or the service, you'll be able to use Amazon EBS, which provides the block storage volume. So a specific storage volume will be given to you when you are using Amazon EC2. Then we have is Amazon EFS, which is known as Elastic File System. It is a scalable file storage for use with Amazon EC2. You'll be able to scale your file storage just by using Amazon EFS when you are working or when you are taking the service of Amazon EC2. Then we have is AWS Glacier. It is a low-cost storage service for data archiving and also long-term backup. That means it will also have no breaches. It will give you a good security and also disaster data recovery at the same time. Number 3 is databases. For databases, first comes Amazon RDS, or which is known as Relational Database Service. It is used or is managed relational database service supporting various engines. An example, MySQL, PostgreSQL, Oracle, and also SQL services. So for databases, analytics, and a lot of those, you'll be able to use Amazon RDS. And if you have any basic ideas about MySQL or PostgreSQL, it's going to be very easy for you to get that service and also work along with it. Then we have is Amazon DynamoDB, which is a fully managed NoSQL database service for key value and also document data models. The next one which we see for databases used by Amazon is Amazon Redshift. It is a data warehousing service for large-scale data analytics. So, if you want to work with the data pool, you can try using Amazon Redshift for databases. Amazon Aurora, which is a high-performance, fully managed relational database engine compatible with MySQL and also PostSQL or PostgreSQL at the same time. So it is going to be a lot more flexible and compatible than the other services which you are going to get online. Number 4, networking and content delivery. Amazon VPC, or which is known as Virtual Private Cloud. It allows user to create isolated networks within the AWS cloud. So users will be able to create a virtual isolated network or an environment with the AWS cloud to test drive before deploying any specific service or any specific application. AWS Direct Connect. It is a dedicated network connection between the user premises and also AWS. So users using the services of AWS and the connection between the premises, or let's say the administrators, the models, and every service between the user and also the provider is basically the AWS Direct Connect. Then we have is Amazon Route 53, which is very popular. It is a scalable domain name system, which is DNS, which is also a web service. And the last one we see over here is Amazon CloudFront. It is a content delivery network, which is also known as CDN in short. It is used for delivering content with low latency. Now, when you are trying to deliver any content with low latency, you are going to try to send it out to the server or to the region server or to the AZ, which is nearest to you. But what happens if it is very far from you, but you also want low latency? You can use Amazon CloudFront even if the AZ is going to be very far from you or even not in your region. It will also give you the best performance of data transfer. Number 5, security, identity, and compliance. For the first one, we see is AWS IAM, which is identity, and access management. It controls access to AWS services and resources securely. It also uses databases to actually identify the user. AWS KMS, which is known as Key Management Service. It is a managed service for creating and controlling encryption keys. So obviously, it's not only going to be a security like just password or PIN, that's it. When you're using these cloud services, it's going to give you the best security. So for that, you can use encryption keys to get inside or get access of your data. Then we have is AWS Shield, which is a managed DDoS protection service. Now, you might think, what is DDoS? Well, DDoS, or which is also known as distributed denial of service, which is attack and designed to force a website, computer, or online service offline. This is accomplished by flooding the target with many requests, consuming its capacity and rendering it unable to respond to legitimate requests. So, in case, let's say it is a cybercrime in which the attackers flood a server with internet traffic to prevent user from accessing connected online services and sites. So, it is managed by AWS Shield so that even in times of DDoS, you'll be able to get the best performance and also the best protection. AWS WAF, which is also known as Web Application Firewall. It protects web application from common web exploits. Then we have is management and also governance of the data. First comes AWS CloudFormation, which is a service for modeling and setting up AWS resources using only templates. Then we have is AWS CloudTrail. It enables governance, compliance, and operational and risk auditing of AWS accounts. These services are also sometimes done by a couple of organizations and also industries. It helps them to get or have the sovereignty of data and also governance at the same time. Amazon CloudWatch. It is used for monitoring and observing service for AWS cloud resources and also applications. Well, obviously, if you have your data online or in the cloud service, though those monitoring services are also given by AWS. But if you want to do that, you can use the service of Amazon CloudWatch. Then we have is AWS Config. It tracks AWS resource configurations and help with compliance auditing. So if you want to audit or if there is any problem in the auditing, it actually helps the compliance to audit up any configuration. 7. Developer tools. The first developer tool which we have over here is AWS Code Commit. It is a source control service that hosts Git response or repositories. Now you might think that what is Git repositories? Well, GitHub, or let's say Git repository, is a central storage location for changes in files and directories. It is a crucial component of the version control system, which enables collaborative development and allows multiple developers to work on a simple simultaneously. So it's also kind of like working at the same time without any information breach. Then we have is AWS Code Build, which is a fully managed build service that compiles source code, runs tests, and produces software packages. So the developers don't have to think of anything else except for programming. It basically saves up a lot of time when they are using AWS Code Build. Then we have is AWS Code Deploy, which is a service that automates code deployments to any instances, including Amazon EC2 instances and on-premises service. And the last one which we have is AWS Code Pipeline, which continuous integration and continuous delivery, which is known as CI and CD respectively, which is a service for fast and reliable application and infrastructure updates. So if there is any software update about an application or even a service, or if there is any bug fix, you receive a notification, and that is why it is used for. The next one, or number 8, is about analytics. Amazon EMR, or which is also known as Elastic MapReduce, which is managed Hadoop framework that processes vast amount of data. So it also works with data pools. Amazon Kinesis, which is a platform for real-time data streaming and also analytics, such as Spotify, Netflix, and all. AWS Glue, fully managed ETL, or extract, transform, and also load service. And the last one we see over here is Amazon Athena, which is used for interactive query service that allows you to analyze data in Amazon S3 using standard SQL, not even MySQL. So you will find it to be a lot more beginner friendly and user friendly. Number 9, machine learning. Amazon SageMaker. We've talked about SageMaker a lot of time in our courses. This service is a fully managed service to build, train, and deploy machine learning models. AWS Recognition, which is a service for image and also video analysis. Amazon Comprehend, which is a natural languaging process or natural language processing, which is also known as NLP in short, which is a service to extract insights from text. So such as couple of analytic tools, those use NLP for extracting the insights, such as how many people have been using a specific keyword, such as SEO. Then we have is AWS Lex, which is a service for building conversational interfaces using voice and only text. Number 10, migration and transfer. AWS Migration Hub. It is a service that provides a single location to track the progress of application migration. To check out the process of the migration, you can use AWS Migration Hub. Then we have is AWS Database Migration Service, which is known as DMS or AWS DMS, which is a service which helps migrate databases to AWS easily and also securely. But obviously the cost is a bit higher. And the last one we see over here is AWS Snowball, which is a service that provides physical device to transfer large amount of data into and out of AWS, such as physical hardware, servers, and all. And those are also provided by AWS in times of need or on demand. These core service domains provide a comprehensive suite of tools and services that provide a wide range of application workloads, enabling organization to innovate faster and operate more efficiently in the cloud. These core service domains provide a comprehensive suite of tools and services that support a wide range of applications and workloads, enabling organizations to innovate faster and operate more efficiently in the cloud. So, the people, or let's say the developer, or even the provider, whomever is taking those services, don't have to overthink or don't have to think of anything except their own role. And all of the other things are going to be done by these services or by these providers. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome back to another class of AWS. In this class, we're going to learn about the full briefs about AWS free tier and AWS Console Global Infrastructure. In our previous class, we have learned about the AWS service domains or the core domain service. So, in this class, everything will be given or everything will be presented in a presentation with brief examples so that you can get more idea about how these services work and how does the subscription work and which one should you be choosing. So, let's learn about what we need to know about the overview of AWS free tier and also AWS Console Global Infrastructure. AWS free tier. Let's see the overview. The AWS free tier offers customer the availability to explore and experiment with AWS services for free. So obviously you are not going to just take any service without knowing how it works. So for that, AWS gives off that experience to those new people or newcomers so that they can experiment with the AWS services for free and also discover what they need. Within certain usage limits, it is designed to provide a hands-on experience with AWS products and also services without incurring cost. The free tier consists of 3 different types of offers. Let's check them out what they are. First one is always free. These services are free for all AWS customers and do not expire. So anytime you want to get experience on these AWS services, you can just go onto their server or go onto their platform and try them out anytime. It will not expire anytime soon. Examples: Amazon DynamoDB, which gives off 25 gigabytes of storage, 25 write capacity units, and 25 read capacity units. If you are totally new to any business and you want these cloud services, you can try out the free example or free tier of AWS DynamoDB. Then we have is AWS Lambda, which gives off 1 million free requests and also 400,000 gigabytes seconds of compute time per month. So every month, you're going to get 400,000 gigabytes of seconds of compute time. But obviously, if you have a large organization or a large user database, it's not going to be enough. But it's going to be enough if you are totally new to these services and you are trying to gain more user. Amazon Glacier. It gives off 10 gigabytes of free retrieval per month. So any data, you will be able to save them up inside of that cloud service and you'll be able to retrieve 10 gigabytes of them every month. Now let's see what we have next. 12-month free. These services are free for the first 12 months following the sign-up date. Example: Amazon EC2, which gives off 750 hours of usage per month. It will not work after you have reached up that specific limit. Let's say Linux, RHEL or SLES, T2 micro or T3 micro instances are also used by these Amazon EC2 service. Amazon S3. It gives off 5 gigabytes of standard storage, 20,000 GET requests, and 2,000 PUT requests per month. And the last one we have is Amazon RDS. It gives off 750 hours of usage per month of DB, T2 micro, or DB3 T3 micro instances. It also gives off 20 gigabytes of database storage. Obviously, that's a lot. And 20 gigabytes for backup. So it is very advantageous for new users and also who want to experiment any of these services. And the last type of service are trails. These services are offered for free for a very short duration, typically for 30 or 60 days, 1 month or 2 months. Let's see what the examples are. Amazon SageMaker. It gives off 250 hours of T2 medium notebook usage for the first 2 months. Then we have is Amazon Redshift, which is a very flexible and very reliable service. It gives off 750 hours per month for 2 months, along with 160 or 160 gigabytes of SSD storage. That is why it is very reliable and also has very low latency. Now, let's check out AWS Management Console. Let's see the overview of it. The AWS Management Console is a web-based interface that allows users to manage their AWS resources. It provides a comprehensive and intuitive platform for accessing and administering AWS services. Key features of the AWS Management Console include these services. Dashboard. It provides an overview of AWS account usage and also resource status, such as if it is migrating or if the resource files are intact, and also check out of breaches. It also overviews or monitors the account usage. Display service health information and also notifications are sent through these dashboards. Then we have is resource management. It allows user to create, configure, and manage AWS resources such as EC2 instances, S3 buckets, RDS databases, and even more. It also supports tag-based resource grouping and also management at the same time. Then we have is service navigation, organized into categories for easy access to AWS service, including compute storage, database, networking, analytics, and even more. It even includes a search bar to quickly find out specific services, even resources. Monitoring and also reporting. It is integrated with AWS CloudWatch for monitoring resource metrics and setting up alarms, such as timely notification. It also provides detailed billing and cost management reports to track usage and also the expenses of these services. Then we have is security and access control. It manages user permission and access policies using AWS Identity and Access Management. In short, it is known as IAM. It also supports multi-factor authentication, which is known as MFA in short. It is used for enhanced security, such as encryption keys. Developer tools. It is an integration with services like AWS Code Commit, AWS Code Build, AWS Code Deploy, and AWS Code Pipeline for streamlined development and deployment of like workflows. So, the developer tools and the integration with the services actually help users and also developers to only think on developing. They don't have to worry about anything else because all of these streamlined development is connected or given with these services. It also gives off access to AWS command line interface, which is known as CLI in short, and SDKs for programmatic access to AWS services. Now, you might think that, yes, let's say a software SDKs is a set of platform-specific building tools for developers. You require components like debuggers, compilers, and runs on a specific platform. So inside of the services of AWS. So you don't have other services in another platform. SDKs or SDKs put everything you need to run a software in one place. So now you know what it's used for or why is it used by programmers. The last one is learning and support. It gives off access to AWS documentations, tutorials, and also training resources. Before setting up or before sitting for the exam of certifications, which I've also described in my previous classes, well, if you didn't check them out properly, you can go check them out. It will give you a better idea about learning and also the support. So these training resources and tutorials are given to people who want to get into the exams and also try to get certifications of cloud providers or from these cloud services. They also provide integration with AWS Support Center for troubleshooting and also assistance. Now let's check out what the summary is. The AWS free tier allows users to explore AWS services at no cost within specified limits. Helping them get familiar with the platform, the AWS Management Console provides a user-friendly, web-based interface for managing and monitoring AWS resources, enhancing the ease of use and operational efficiency for AWS user. So obviously you are not going to invest into something where you have no experience. AWS basically wants user to actually, let's say they want more people or more user to actually get more comfortable with their services so that they become a more reliable service. And that is also about a marketing strategy. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. But just make sure that you do not skip any part of these classes. And one class, or let's say each and every one of these classes are going to complement the other one. So if you have no basic ideas, which I've taught in my previous classes, then these next classes you will not be able to understand properly because now we are getting into more practical based classes. So without any further ado, let's move on to our next class of AWS. Welcome back to another class of AWS. In this class, I'm going to give you a brief idea and also a vivid explanation about AWS compute services and how those actually function. It is going to be a brief class, so I would suggest you from the beginning in this class. Even if you do, I also have the resource folder in this course, which you'll be able to get from this course. So you can check out the lectures and also the presentation. And also, if you have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So let's move on to our presentation. But before that, let's check on the overview of it. AWS, or Amazon Web Services, offers a variety of compute services that enable users to run virtual servers, containers, and even serverless functions. These services provide the flexibility to choose the right compute resource for different types of applications, allowing for efficient and also cost-effective computing solution. Here's a brief overview of the primary AWS compute services. Let's check out the first one, which is Amazon EC2. We've already talked about it a lot of time in this course, but I have done a bit of research on this, so make sure not to skip anything. EC2, or Elastic Compute Service. It provides resizable compute capacity inside of the cloud. So whenever you want to change the size or scale your files or data directly inside of the cloud without even doing it on specific physical hardwares, you'll be able to do that just by using Amazon EC2. EC2 instances are virtual servers that can be configured with various CPU, memory, storage, and also networking options. You'll be able to create your own one when you're using these services. The use case of Amazon EC2 is for web hosting, batch processing, distributed computing, development, and also testing environments. The key feature of Amazon EC2 is wide range of instance types for optimization for different workloads. You'll be able to optimize higher workload and also lower workloads at the same time. Auto scaling to automatically adjust the number of instances based on demand. So let's say you need 3 instances, but you'll be able to optimize them and also auto scale them just to adjust it according to the size on your demand. Elastic load balancing is used to distribute incoming traffic across multiple instances so that you don't face any specific errors. And also, it's going to give you out the best performance, even if you have a higher traffic. Integration with other AWS services such as S3, RDS, and VPC allows you to get the best performance and also the best features for your accommodation. AWS Lambda. The description of AWS Lambda is that it is a serverless compute service that runs code in response to events and automatically manages the compute resources. So you can see, or you can think or come to the conclusion that it is very flexible and very useful. The use cases of AWS Lambda is real-time file processing, data validation, web backend, event-driven applications. So you could say such as like a software update, bug fixes, and everything, even though everything or every data is still going to be usable to the users. The key features of AWS Lambdas are given below. You don't need to provision or manage the servers. All of them will be done automatically. Even if there is a problem, everything will run the codes according to the event. Even if there is a breach, it will give you out the notification so that you can know. And obviously, it's going to use other integrated services. Key features are the next one of key feature of AWS Lambda is automatic scaling and also high availability. You'll be able to get the service from anywhere in the world because there's a lot of these AZs of AWS Lambda. And also, all of the files or all of the data is going to be automatically scaled. It also supports on multiple programming languages such as Node.js, Python, Java, Ruby, C#, and etc. Then it also has integration with many AWS services such as S3, DynamoDB, Kinesis, and even API gateways. Amazon ECS, or which is also known as Elastic Container Service, which is a fully managed container orchestration service that supports Docker container and allows users to run and scale the containerized application. So it also does a bit of organization inside of your cloud service storage. The use case of Amazon ECS is for microservices, architecture, batch processing, machine learning model training. The key feature of Amazon ECS is that it supports both EC2 and also Fargate launch types. Fargate allows for serverless containers, so you'll be able to store the data too. Integration with AWS Identity and Access Management, which is known as IAM for short. It is used mostly for the security. Integration with Elastic Load Balancing, CloudWatch, and also other AWS services. It even supports Docker and AWS Fargate for serverless compute option. Now you might think, what is AWS Fargate? So, AWS Fargate is a technology that you can use with Amazon ECS to run containers without having to manage servers or clusters of Amazon EC2 instances, which means private server, or let's say your own cloud. With AWS Fargate, you can no longer have to provision, configure, or scale clusters of virtual machine to run the containers. So the difference between EC2 and Fargate is that it is a granular control over infrastructure, making it ideal for traditional application and specialized computing tasks. On the other hand, Fargate offers serverless simplicity and resource optimization, making it suitable for microservers or even services architectures and bursty workloads. Amazon Kubernetes, or even basic Kubernetes, is an open source container orchestration software with which you can manage, coordinate, and even schedule containers at scale. Kubernetes places containers into pods and run them on specific nodes. So it takes up very less space. Use cases of Amazon EKS is for managing and scaling containerized applications using Kubernetes. The key feature of Amazon EKS is it is fully compatible with Kubernetes. It is also automatically scaled or automatically scales control plane instances based on specific loads. If it is on higher load, it's going to be run on specific nodes. If it is low, it's still going to run on loads, but it's going to be a lot more faster. And it's also going to save up a lot more space inside of your cloud service or even on the DNS. Integration with AWS services such as CloudWatch, IAM, and VPC to run out the full facility or the full feature. It also support for managed node groups and Fargate for serverless pods. So these containers are also going to be run on pods for faster and also lower latency. AWS Fargate. It is a serverless compute engine for containers that work with both Amazon ECS and Amazon EKS. The use cases of Amazon Fargate is simplifying container management by abstracting the underlying infrastructure. The key feature of AWS Fargate is there is no need for provision or even to manage these servers. So it is totally automated and also takes up very less time, but gives you off the best performance. You only pay for the resources required to run that specific container. So you don't have to buy the whole thing or you don't have to pay for the full feature. It's only going to be used or whatever you are going to use in that specific service or for AWS Fargate, you're only going to pay for that. Seamless scaling and also high availability. So you'll be able to use AWS Fargate from anywhere in the world without even, let's say, thinking about its availability. It is also integrated with AWS ECS and also AWS EKS. The next one we have is AWS Batch. The description of AWS Batch is that it is a fully managed service that enables you to run batch computing workloads on the AWS cloud. The use cases of Amazon or AWS Batch is large-scale parallel batch processing, data analysis, machine learning tasks, and even scientific simulation. So you can see it is a lot more based on databases. The key feature of AWS Batch is that it is automatically provisioned compute resources and also optimizes the workload distribution. It is also has the integration with EC2 and Spot instances for cost-effective resource usage. So it also is going to be paid up to the servers which you are using. Job queues and job dependencies for complex workflows. Integration with other AWS services such as S3, IAM, and also CloudWatch. AWS Elastic Beanstalk. The description of Elastic Beanstalk is that it is an easy-to-use service for deploying and also scaling web application and services. Most of the new services or servers are used by this Elastic Beanstalk. The use cases of Elastic Beanstalk is web applications, APIs, background processing. The key feature of Elastic Beanstalk is that it supports multiple programming languages such as Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. So you can come to the conclusion that it is one of the most flexible and one of the most user-friendly and also beginner-friendly service. It is also automatic scaling and also load balancing. So it basically loads the balance of high traffic and low traffic and also the workflow. It is also a managed platform which updates and also environment health monitoring. So it also monitors the virtual environment of your own server. Integration with AWS CloudFormation for infrastructure as codes. As this is already or as this service already supports a lot of these languages, it also monitors and also as it is integrated with AWS CloudFormation, it infrastructures as codes. So you'll be able to import of the codes anytime you want to, and you'll be able to develop it more. AWS Lightsail. The description of AWS or Amazon Lightsail is that it is a simplified cloud service that offers virtual private server or VPS, containers, databases, and even networking resources. The use case of Amazon Lightsail is small to medium-sized application web hosting, and also simple workload. It does not give you off the best service or best performance in a big workload or bulky workloads. The key feature of Amazon Lightsail is that it is pre-configured development stacks and application templates. So it is a lot more easier to actually get the end result very fast. It is also easy to use interface for managing your own resources inside of your cloud. It is also predictable pricing with bundled resources. It is also pay-as-you-go service. It is also integrated with other AWS services like Route 53 and even CloudFront. These AWS compute services provide a wide range of options for running various types of applications, from traditional server-based applications to modern, containerized, and even serverless architectures. Thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or if you want to check out these presentations or these lectures, you can find them out in the resource folder which I have attached with this course. So thank you for watching this video again, and without any further ado, let's move on to our next class of AWS. Welcome to another class of AWS. In this class, we are going to learn about AWS Elastic Load Balancer. In our previous class, I have given you a small example of how Elastic Load Balancer works. Now, we're going to learn about its briefs and also how it functions. So let's get into our overview. AWS Elastic Load Balancer, or in short, ELB, is a service that automatically distributes incoming application traffic across multiple targets, such as Amazon EC2 instances, containers, and even IP addresses in one or more availability zones. This helps ensure high availability and fault tolerance for applications. There are three types of ELB or Elastic Load Balancer. Let's check them out, how those actually function. ALB, or Application Load Balancer. It is ideal for HTTP and also HTTPS traffics. So, an example, Google searches. It operates at the application layer, which is also known as layer 7 of the OSI model. Now you might think, what is an OSI model? Basically, an OSI model, or Open System Interconnection Model, is a conceptual framework that divides layers, or let's say 4 communication functions, into specific 7 layers. Sending data over a network is complex because various hardware and software technologies must work cohesively across geographic. Now, what are the first layer is a physical layer that transmits raw. The second layer is called of data is decides which physical path the data will take. As the transport layer, it transmits data using transmission protocols, including the TCP and also UDP. The fifth layer is called the session layer. It maintains connections and is responsible for controlling ports and even sessions. The sixth layer is called the presentation layer. It ensures that data is in a usable format and is where data encryption occurs. And the seventh and the last layer is called the application layer. It is a human-computer interaction layer. It is also used by AI nowadays, where application can access. ALB also provides advanced routing capabilities based on URL path, host name, HTTP headers, HTTP methods, and query string parameters. The supports of WebSockets and also server-sent events of ALB. NLB are also known as Network Load Balancer. It is ideal for TCP, UDP, and TLS traffic where extreme performance is required. It operates at the transport layer of layer 4 of the OSI model, which I've also given you an example of. If you forgot about it, basically the transport layer, including the TCP and also UDP. NLB is capable of handling millions of requests per second with ultra low latency. So you can see how many AZs are available and how it actually gives you off the best performance. It is also designed for applications that need to maintain ultra high performance, such as Netflix, and even other services, such as even services used by hospitals and also government agencies. GWLB are also known as Gateway Load Balancer. It combines the functions of virtual applications or appliance with the scalability and also availability of a load balancer. It is useful for third-party virtual appliances such as firewalls, intrusive detection and prevention systems, and deep packet inspection of the system. It also works depending on which region you are at and which place or which server you are using. It also operates at the network layer of layer 3 of the OSI model. And layer 3 is basically the networking layer, which decides which physical path the data will have to be taken to. So what are the key features of these? High availability. It distributes traffic across multiple targets and availability zones. So you have the best service and also the best performance wherever you are at. Scalability. Automatically scales to handle the varying loads of your application. Now, obviously the workloads are not going to be the same on all times. It could be high, it could also be low at certain times, but it automatically scales your data and handles that workflow without any error. Even if there's error, it also automatically encodes them and fixes it up. Security. It integrates with AWS services like AWS Shield for DDoS protection and AWS Web Application Firewall, or which is known as WAF in short, for web security. Health check. Regularly, it checks the health of target and routes traffic only to healthy ones. It's also going to automatically choose the best service and also the best path for your data to be transferred, even if you want to migrate them. And it's also going to check out which one is healthy without having any information breach. Sticky sessions, also known as sessions affinity. It ensures that a user's session is consistently routed to the same target. It also gives you off the best route for the best resources any user wants to take according to their demand. So what are the benefits? Improved fault tolerance. By distributing traffic, ELB reduces the impact of a failure in any single component. So if there is any problem with the route, it's just going to distribute the traffic to a healthy one, just like you have seen. Simplified architecture. It simplifies scaling and maintenance of application by handling traffic distribution. Even if a developer wants to use any specific service for, let's say, any of these cloud services or by using any specific cloud service, Obviously, not all of them are going to give you off the best service. But when you are using ELB, it's going to be very simplified, and it's also going to suggest the best node and even the best service. Cost effective. You pay only for the load balancing capacity you use without upfront cost. Because obviously you're not going to pay for things or services which you are not going to be using, even if you have subscribed. So even if you have a higher storage and if you don't use it, you won't have to pay for it. Neither you have to pay upfront costs. AWS ELB makes it easier to design and also implement a robust, scalable, and highly available application infrastructure. AWS ELB makes it easier to design and implement a robust, scalable, and highly available application infrastructure anytime. So, thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. Just make sure not to skip any part of these classes because this is going to be very important because very soon we are going to start our practical classes. So without any further ado, let's move on to our next class of AWS. Welcome to a new class of AWS. In our previous class, we've learned about AWS Elastic Load Balancer. If you didn't watch out that video properly, I would suggest you check that video out again. If you have any confusion or question, feel free to ask me because without knowing or having the idea as how it works or about the Elastic Load Balancer, this class is going to be a bit of hassle for you. So in this class, we're going to talk about the types of Elastic Load Balancer there are, what you can use, and also I'm going to give you out a brief about them so that you also know about its examples or where it is used. So I have prepared a presentation for you guys, so make sure not to skip anything because if you do, you might face a bit of hassle later on. So let's move on to our presentation. The first one is called Application Load Balancer. In short, it is called ALB. It is ideal for HTTP and HTTPS traffic. The operation level of ALB is application layer, which is layer 7 of the OSI model. The features of ALB are advanced routing based on URL path, hostname, HTTP headers, HTTP methods, and query string parameters. It also supports WebSockets and server-sent events. The example of ALB is that a web application serving different microservices, such as an e-commerce site, would separate services for user authentication, product listings, and order processing. ALB can route requests to the appropriate service based on the URL path. In example, AUTH or authentication, products, and also orders. The second one is called Network Load Balancer. In short, it is NLB. It is ideal for TCP, UDP, and TLS traffic, where extreme performance is required. Now here, TCP, UDP, and TLS. So what is TCP? Transmission Control Protocol is a communication standard that enables application program and computing device to design to send packets across the internet and ensure the successful delivery of data and messages over network. So this is what TCP is. Now, UDP. So what is UDP? UDP, or the User Datagram Protocol, is a communication protocol used across the internet for especially time-sensitive transmission, such as video playbacks or DNS lookups. It speeds up communication by not formally establishing a connection before data is transferred. So this is what UDP is. Now, you might think, what is the difference of a TCP and UDP? Because both of them is just used for extreme performance required in cloud services. So, the difference between the protocols, the main difference between TCP or Transmission Control Protocol and UDP, which is User Datagram Protocol, is that TCP is a connection-based protocol and UDP is connectionless. While TCP is more reliable, it transfers data more slowly. UDP is less reliable but works more quickly. So now you know about the differences. And TLS, or Transport Layer Security, is a widely adopted security protocol designed to facilitate privacy and data security for communications over the internet. A primary use case of TLS is encrypting the communication between web applications and servers, such as web browser loading a screen. So now you know about how TCP, UDP, and TLS is used, or what is its functions. The operation level of NLB is that transport layers or layer 4 of the OSI model. The features of NLB are handlines millions of requests per second with ultra low latency. Now, the example of NLB is that a financial application requires low latency connections for real-time trading. NLB can efficiently distribute TCP connections to a pool of backend servers handling the traders. Number 3. Gateway Load Balancer, or GWLB. It is ideal for integrating third-party virtual applications like firewalls, intrusion detection and prevention system, and deep packet inspection system. So now you know that this is used for the gateway and also about inspection. The operation level of GWLB is that it's the network layer or layer 3 of the OSI model. Features: combines the function of a virtual appliance with the scalability and availability of a load balancer. The example of GWLB is that a company using a third-party firewall application or appliance to inspect and filter incoming and outgoing traffic. GWLB can distribute traffic to multiple instances of the firewall appliance to ensure high availability and also the scalability. So let's check out the summary table. So this is how the summary table has been organized. You can see I have created a couple of categories where load balancer type, what is it ideal for, OSI layer, key feature, and example use cases. So let's go through that again. Where we have ALB, it is ideal for HTTPS. On the OSI layer, it is layer 7. The key feature of ALB is advanced routing and also WebSockets. The example use case is microservices architecture. For NLB or Network Load Balancer, TCP, UDP, and TLS, this is what it's ideal for. The layer of OSI model of NLB is layer 4. It is used, or the main key feature of NLB is ultra low latency and high performance. The example use case of NLB is real-time financial applications. Then we have is GWLB, or Gateway Load Balancer. It is ideal for virtual appliances. On the OSI layer, it is layer 3. The key feature of GWLB is integration with third-party appliances, and the example use case of GWLB is traffic inspection and also filtering. These examples illustrate how each type of load balancer can be utilized based on the specific needs and characteristics of different applications. So thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion, or any question about any part of this lesson or even other classes, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to a new class of AWS. In this class, we're going to learn about the brief, and we're also going to give you the clear and vivid idea. Up till now, or up till this class, you've heard about a couple of services that offer you auto scaling. But how does it work and how does it function? So I've done a bit of research on how auto scaling functions. So I will try to convey to you so that you get the best idea about it. Make sure not to skip any part of this class because every part is going to be very important. And if you skip anything, it might be a bit of hassle for you later on. So let's move on with our presentation. What is the overview of AWS auto scaling? AWS auto scaling is a service that automatically adjusts the number of compute resources in your application to maintain steady, predictable performance at the lowest possible cost. It allows you to automatically scale your Amazon EC2 instances, EC2 tasks, DynamoDB tables, and other AWS resources based on the demand for your application. So, to make your application function properly, it uses a couple of services at the same time and automatically scales it up. So now you can understand or you can come to the conclusion that it is very convenient and very beginner friendly. Even if it's not that beginner friendly, if you have no idea, but obviously it will do most of the works it has to do to scale up your number of resources. So let's check out the key features of auto scaling. Automatic scaling automatically adjusts the number of EC2 instances, ECS tasks, or other resources based on demand. It can scale out or even add resources during high demand and scale in, which is remove resources during low demand. So you can understand it is also going to save up a lot more space and you are only using the things which you need to use. So the stuffs or the resources which you do not need, you will not have to pay for that. Scheduled scaling. It allows you to schedule scaling applications or actions based on predictable load changes. For instances, you can schedule to scale out every morning at 9 a.m. and scale in every evening at 6 p.m. So you don't have that specific workload or even that resource load or traffic at those times. And you are also refreshing your own server or service so that you get the data whenever you need so that you get the best performance every time. Then we have is dynamic scaling. It uses scaling policies to automatically adjust the number of resources based on real-time metrics such as CPU utilization, memory usage, or custom CloudWatch metrics. Now, up till now, you have thought about these services are only going to be optimized based on the network connections. But no, it is also going to be optimized depending on your device where you are working on. It also going to check out the utility or even the analytics of your performance or your computer or even your phone. How much CPU is being utilized, how much memory is being utilized, and how much custom CloudWatch metrics are being utilized. It's going to check out or analyze all of those things, and then it's going to give you up data and adjust the number of resources according to your need. Supports target tracking, step scaling, and also simple scaling policies. Obviously, each and every one of these processes has their own type of policy and regulation. It's going to support like target tracking, such as tracking, and then step scaling. It's going to scale up step by step, and then simple scaling policies. Predictive scaling. It uses machine learning models to forecast the future traffic and automatically adjust the number of resources in advance of predicted load changes. So sometimes what happens, it forecasts the future traffic. It is if it's going to be low or is it going to be high. Then it automatically adjusts the number of resources in advance of predicted load changes because obviously not all the time it's going to give you out the best performance when there is high traffic and higher workload. So what it does is that it reduces that workload and also sends it up to a couple of other AZs so that in times of need or even in high traffic time, you don't see any, let's say, low latency during that time. Resource management integrates with multiple AWS services like EC2, ECS, DynamoDB, Aurora, and also more. It ensures that applications always have the right amount of resources to handle the current load, even if it's high or even if it's low. It obviously has to work, but the performance is not going to be the same all the time. It's going to be a bit slower in high traffic time, and it's also going to be a lot faster when there's low traffic. But it also has that service that if you back it up or if it has already been scaled up in. Welcome to a new class of AWS. In this class, I'm going to give you a brief idea and a clear and vivid idea about Amazon E2C. In our previous classes, we've learned about how it works, but in short terms. So let's start learning what E2C is and how does it function. Amazon EC2 or Elastic Compute Cloud is a web service that provides resizable compute capacity in the cloud. So basically, you don't need any physical hardware or a physical server to actually resize the compute capacity. It allows user to run virtual servers known as instances. So whomever the user is or whomever is taking the service, they will be able to run their own virtual server or maybe their own virtual environment, which is known as instances. And all of those are going to be inside of the cloud. So depending on the size or the storage of the cloud, it's going to create that own virtual server. So you'll be able to test out, deploy them, and also you'll be able to run couple of, your own application and services inside of Amazon EC2. On demand, these instances can be scaled up or down based on the application's requirement. So in cases of couple of updates of software, you will need to test them out. You will need to scale a couple of things up and down. And you'll be able to do all of those without any physical hardware. You'll be able to resize them and use that compute capacity inside of that cloud service inside of your own virtual server. So you can already think that it is very convenient and also very cost effective. What are the key features of Amazon EC2? First off comes scalability. Easily scale your compute capacity up or down without thinking of anything else. Every feature is going to be given with Amazon EC2, so you'll be able to scale it up and down without even thinking of other storages. Flexibility. Choose from a variety of instances types optimized for different tasks. Obviously, your application or the service from your application, all of them are not going to be the same. So you'll be able to choose a variety of instances because there are a lot of instances from where you'll be able to select from. Choose the most optimized one on where or on demand of which facility or feature you are using depending on your software. Pay as you go. You only pay for the compute time you use. So in case you have that software or you have that service, but you are only using it at specific times, such as in the morning or maybe another time at night. You are only going to pay for that service, not anything else. Integration. It works seamlessly with other AWS services like S3 for storage, RDS for databases, and even more. Let's check out the examples of where Amazon EC2 is being used. Web hosting. Run a website or web application on Amazon EC2 instances. Because when you are hosting a web, there is going to be a lot of features. And obviously, how does these websites or web browsers become very optimized? If you use Amazon EC2, it is very simple. And also, almost a lot of web applications or websites use Amazon EC2 as their own service or as their cloud service because it allows websites and also web application to scale their data and resource up and down in times of need and also update their own experience from time to time. Data processing. Use EC2 for batch processing tasks or data analysis. Now, you can open up AWS Batch Console, first run wizard for select orchestration type. You can choose Elastic Compute Cloud, which is EC2. Now, you might think that which EC2 instance is used for batch processing. Well, the batch is an orchestration service. It will use the P2X large instance under the hood, and that is what your application needs. Such as compute optimized instances are suitable for workloads that require high performance processing capacity, such as batch processing and high traffic web server. Application development. Develop and test application on scalable virtual server. So you'll be able to trust the server, you'll be able to run them, you'll be able to test your application and deploy it and check for bugs. And the last thing which you need to know is about gaming. You can host multiplayer game servers or backend server for online gaming. So one of the most important thing about using the EC2 instance for gaming is that it creates its own instance. You'll be able to create your own virtual server without paying a lot. So what happens is that when you are working with these services, you only pay up till you go and not for the extra services which you do not use. So that is why it is very advantageous of using EC2 instances for gaming, application development, data processing, and also web hosting at the same time. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS or Amazon Web Service. Welcome to another class of AWS. In this class, we're going to learn about Amazon EC2 instances. If you still don't know what instances are, well, instances are basically servers or virtual servers, which you'll be able to create in Amazon EC2 service. I have prepared a presentation for you guys so that you can understand it more clear and vividly. Because if you still don't know what Amazon EC2 functions are or what are its instances, I would suggest you go check out my previous videos properly. But if you still don't understand them, feel free to ask me anytime. I'm always there to help you out. I have done a bit of research on these instances, so let's get into our presentation and let's start learning about Amazon EC2 instances. Let's check out the overview. Amazon EC2 or Elastic Compute Cloud provides scalable virtual servers inside of the cloud. So you don't have to basically think about physical hardwares, which are kind of very expensive. Here's a brief overview along with some examples of instance types. Purpose. Run the applications and workloads on virtual server. It not only just helps you to save extra cost. It also helps you to create that environment for you so that you can run and test anything. Not just only that, you will also be able to use that service or use that environment to also filter up your own resources and data. You can also make your servers make it a lot more, let's say, low latency and also with the best performance. Because as it creates up a virtual environment, you don't have to think about any physical hardware. So these services are also very fast and also the data transfers are also quite good. But it also depends on your own audience and your user scalability. Easily scale up and down based on your specific demands. So let's say you have created yourself a web application or maybe even a website. But obviously, your website or your web application is not always going to be the same. You're going to try to keep it or make it better day by day. So in other services or in couple of cloud services, you will not be able to scale it up and down in times of need. But when you use these Amazon EC2 or these instances services, you'll be able to scale them up and down based on demand. And you're also going to pay up till you go. So whenever you are not using that service, you basically don't have to pay for it. You only pay for where or when you are using these services. Variety. Different instances types for varying needs. An example, compute, memory, and even storage. There are different types and various types of instances available for your own software and for your own need. Let's say you are trying to use these instances for your storage. So obviously you are going to try to select these type of services only which is optimized for storage. If you need optimization for your memory, there are also various instances which are going to optimize your memory. Just like I said in my previous class, not only does it give you out that facility of only storage and only the server, it also gives you up and also analyzes your computer specs and also optimizes the things or optimizes those cases when you need it and where you need it. In case of CPU optimization, you will also have those facility and also features given to you by Amazon EC2. Examples of EC2 instances. 1. General purpose. T3 Micro. It is very cost effective for low traffic application. It is also suitable for web servers and also development environment. So why is it available or why is it suitable for web servers and development environments? Because as this does not take a hardware, it takes very less space and very less cost. So you'll be able to run them just as long as you need, and you can also optimize your own, let's say, software or application or even your website whenever you want to. M6i Large. It is a balanced compute, memory, and also a networking service. It is good for small to medium databases and enterprise application. Compute optimized. C7G X Large, which is a high performance for compute intensive tasks like batch processing and also gaming. So you can see there are a lot of these examples and a lot of these instances which you'll be able to use for a couple of different cases. Now we have is memory optimized. R6i.2x large. High memory for data intensive applications like high performance database and in-memory caches. So if you want to optimize your memory of your device and also to get the best performance out of these services, use R6i. For storage optimization, use i3 large. It is a high storage capacity and performance, ideal for databases and also data warehousing. So even if you want to create yourself your own data pool inside of your own environment or your own serverless environment, you'll be able to create it using i3 large. Then we have is accelerated computing. So if you want to optimize your computing, use P4D.24x large. It is equipped with GPUs for machine learning and high performance computing tasks. Now, each instance type is designed to handle specific types of workloads. For choosing the right one depends on your application requirement. So up till now, I've shown you a couple of these services which you'll be able to use depending on various cases. Maybe for networking, maybe for gaming, maybe for storage, or maybe for computing. So each of them has various type of services. So try using the one which is actually necessary for you and is also going to be demanded by your software for more optimization. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to a new class of AWS. In this class, we're going to learn about Amazon EC2 instance types. In our previous classes, we've talked about Amazon EC2, E2C, ECS, and also how it works, how it functions, and why are those. So let's get into our class with knowing about its overview. An AWS instance type defines the hardware configuration of Amazon EC2, or Elastic Compute Cloud, virtual server. Each instance type offers a different combination of CPU, memory, storage, and networking capabilities tailored to various use cases. In case like you want to optimize the networking. Obviously, there are going to be services that are going to optimize your network. So let's check out the key aspects of AWS instance types. vCPUs, virtual CPUs allocated to the instance. More vCPUs generally mean better processing power. RAM, the amount of memory available, which impacts the instance ability to handle large data sets and also application. Storage, types and amounts of storage, including options like SSDs, which is solid state drives, and HDD, which is hard disk drive. Networking, network performance and bandwidth capabilities. Specializations, some instance types come with specialized hardware like GPUs for accelerated computing or high memory configuration for memory-intensive application. Examples of AWS instance families. General purpose. It is used for balanced compute, memory, and networking. Examples are T3, M5. Compute optimized. It is a high performance for computing intensive tasks. The examples of compute optimized services are C5 and C61. Memory optimized. High memory capacity for applications requiring large amount of RAM. Examples of memory optimized service is R5 and X1E. Storage optimized. High storage throughput and capacity. The examples of storage optimized services are i3 and D2. Accelerated computing. GPU-based instances for machine learning and also graphics. These service or these cloud services or GPU-based instances are P3 and also INFI or INFI. Amazon EC2 or Elastic Compute Cloud offers a variety of instance types to cater to different computing needs. Here are a few examples. General purpose, balanced compute, memory, and networking resources. T3 Micro, which is a low-cost, burstable performance instance with 2 vCPUs and 1 GB of RAM. M5 Large. It provides a balance of compute memory and networking with 2 vCPUs and 8 GB of RAM. Compute Optimized. For compute-bound application, which is C5 Large. It is a high-performance processing with 2 vCPUs and 4 GB of RAM. On C61 4X Large, it is an enhanced performance with i6 or 16 vCPUs and 32 GB of RAM. Memory Optimized. For applications requiring large amounts of RAM, R5.Large, which is a high memory capacity, which has 2 vCPUs and 16 GB of RAM. For XIE.32X Large, which is a massive memory with 128 vCPUs and 3,904 GB of RAM, which is also equivalent to a server. Storage Optimized. For application requiring high sequential read and write access to very large data sets, which is i3.Large, which is a high storage throughput with 2 vCPUs, 16 GB of RAM, and 475 GB of NVMe SSD storage. Then we have is D2.8X Large, which is a large-scale data processing with 36 vCPUs, 256 GB of RAM, and 48 TB of hard disk storage. So the difference between i3 Large and D2X Large is that i3 Large is going to have less storage, but it's going to be a lot faster than D2.8X Large because D2.8X Large uses 48 TB of HDD storage. So hard disk drives are comparatively a lot slower than SSDs. Accelerated computing. For GPU-based application and machine learning, P3.2X Large provides GPU storage with 1 NVIDIA V100 GPU, 8 vCPUs, and 61 GB of RAM. INFI.6X Large, which is optimized for machine learning interference with 16 vCPUs, 122 GB of RAM, and 1.5 TB of local NVMe storage. So you can see this one is optimized for only machine learning. But you can see on P32X Large, which has, let's say, a source or resource of GPUs, which can also be used for graphics. So, choosing the right instance type depends on the specific requirements of your application or workload. Obviously, not all the apps are going to be the same, neither all of the works are going to be the same. So you might also be able, or you might also have to choose a couple of instances at the same time in your own specific application. Because each and every one of these instances or each and every one of these services complements the other one. So make sure to not skip any part of these classes. If you still have any confusion or any question till now, feel free to ask me anytime. I'm always there to help you. And thank you for watching this video up till the very end. So without any further ado, let's move on to our class projects. Welcome to a new class. In this class, we're going to cover everything to get you started and everything for you to understand about Amazon Elastic Block Store. So I have prepared a presentation for you guys so that you can understand it properly and apply it while working. So let's check out the overview of Elastic Block Store. Amazon Elastic Block Store, or Amazon EBS, is a scalable high-performance block store service designed for Amazon Elastic Compute Cloud, which is in short called EC2. EBS provides persistent cloud storage volumes that can be attached to EC2 instances or private environments inside of your cloud, allowing for data retention even after the instances are stopped. So even if you get out of your own instance or your own private cloud service, or maybe even the private environment where you are testing your data, they will still be retention. Let's check out the key features of Amazon EBS. Durability and availability. EBS volumes are designed for high durability, automatically replicating our availability zone, AZ, to protect against hardware failures. So obviously these volumes are designed in such a way that it is very durable and it can automatically replicate data even if there is any hardware failure, which in case or as a result, you have really less chance of losing or let's say security breaches of your own data. Types of EBS volumes. General purpose SSD, GP3, and GP2, which is suitable for a wide range of workloads, offering and also the performance. Now, what is GP3 and what is GP2? GP3 and GP2, both of them are general purpose SSD volumes. Both GP3 and GP2 can reach up to 16,000 IOPS and offers the same level of durability. However, GP2 volumes reach a lower maximum throughput per volume, such as 250 megabytes per second, than GP3 volumes, which offers you 1000 megabytes per second. So that is the difference between GP3 and also GP2. Provisioned IOPS SSD, which is IO2 and IO1, which is designed for critical application requiring sustained high performance such as databases. Now let's check out the difference between IO2 and IO1. IO2 block express volumes can deliver higher throughput and IOPS and supports larger storage capacity. For more information, you can check out IOPS SSD IO1 volumes on your browser. It will help you to understand more about it. Now, the exact difference of IO1 and IO2 is that IO2 can deliver maximum of 500 IOPS per 1 gigabytes, whereas IO1 volumes can deliver maximum of 50 IOPS per 1 gigabytes. So that is the difference. Now, throughout optimized HDD or STI, ideal for large sequential workloads such as big data and also log processing. Cold HDD, which is SCI in short, suitable for less frequently accessed data with lower performance needs like backups and also archiving. Performance. EBS provides consistent low latency performance. With provisioned IOPS SSDs, users can specify the number of IOPS, ensuring predictable performance for higher demanding applications. Snapshots. Users can take point-in-time snapshots of EBS volumes. These snapshots are stored in Amazon S3, providing a suitable backup and the ability to create new volumes from these snapshots. So this is a lot like replicating the data. Encryption. EBS supports data encryption both at rest and even in transit. The encryption is integrated with AWS Key Management Service or KMS, allowing for seamless key management. So you have like lower chances of losing or forgetting your password, and also it's going to give you higher performance and also the best service of security. Scalability and flexibility. Users can dynamically scale capacity, performance, and IOPS of EBS volumes without downtime. This flexibility ensures that storage needs can adapt to changing workloads. Integration with other AWS services. EBS integrates with a variety of AWS services, such as EC2, AWS Backup, and AWS Lambda, providing a cohesive environment for managing storage and also the compute resources which you are going to do on the cloud service. Now let's check out the use cases. Databases. EBS is often used for running relational and non-relational databases due to its high performance and also reliability. So most of them are run on SSDs. Enterprise applications. Applications that require high availability and consistent performance benefit from EBS. So in this course, you have learned one of the most important thing is that each and every one of these, let's say, services complement each other. And every one of these applications or even the services can also be intertwined together to get out the best performance out of these cloud services or even the provider. Big data analytics. EBS volumes are suitable for storing large data sets used in analytics and data processing workflows. Backup and recovery. EBS snapshots provide a robust mechanism for data backup, disaster recovery, and cloning of volume. Without the backup and recovery, obviously you are not going to initiate your own data inside of that cloud service because there is high chances of security breach or information breach when you actually check out a vendor. And that is one of the most important things to check. So with that backup and recovery, make sure not to, let's say, initiate on that vendor or that cloud service provider. Overall, Amazon EBS is a powerful and flexible block storage solution designed to support a wide range of applications and workloads on the AWS cloud platform. So if we come to more conclusion, so the importance of EBS offers high performance block storage tailored for random access tasks. While EBS volumes can achieve a maximum of 64,000 IOPS and 100 megabytes true per volume. So the key benefit of EBS, or let's say the Oracle software, is to provide a seamless integrated platform that spans across various business functions such as finance, human resources, supply chains, project management, and customer relationship management. Now, in addition, what people most of the time ask is that if it is a managed service. EBS, the managed service, which is provided by the cloud provider, includes antivirus, firewall, cloud backup, web security, and also email signatures. And it is also managed by encryption features, so user can enable them and also disable them anytime they want to, which enables data to rest securely by encrypting your data volumes, boot volumes, and snapshots using Amazon managed keys or keys you create and manage using them. So, hope you understood about everything in this class, and thank you for watching this video up till the very end. But if you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So, without any further ado, let's move on to our next class of AWS or Amazon Web Service. Welcome to another class of AWS. In this class, we're going to learn or show you everything you need to know about S3 Glacier. In our previous classes of this course, we have learned about the summary of how it works or how it complements the other services and how it actually works. More into brief about S3 Glacier. Because obviously, if we don't know the brief about it, we will not be able to use this specific model. So make sure not to skip any part of this class because I prepared a presentation for you guys so that you can understand it properly, and also it's going to be very beginner friendly. Let's check out the overview of Amazon S3 Glacier. Amazon S3 Glacier is a secure, durable, and low-cost cloud storage, which is a service for data archiving and long-term backup. It's designed to provide storage for data that is infrequently accessed and for which retrieval times of several hours are suitable. Here are some key aspects of Amazon S3 Glacier. Cost-effective. Glacier is one of the most cost-effective storage solutions provided by AWS, with pricing optimized for infrequent access data storage. Now you might think, why is this so slow and why is this cost-effective? Because this service uses HDD as a hardware. It is not as fast as an SSD or SSD, which is a solid-state drive. Durability and reliability. Glacier is designed for durability, providing 99.9999, which is 11 nines, of durability by automatically storing data redundantly across multiple devices and location. Security. Data stored in Glacier can be encrypted at rest using AWS Key Management Service or KMS, or customer-provided keys. It also supports secure data transferring using SSL. Now, what is SSL? SSL, or Secure Socket Layer, is an encryption-based Internet security protocol. It was first developed by Netscape in 1995 for the purpose of ensuring privacy, authentication, and data integrity in Internet communication. SSL is the predecessor of the modern TSL encryption used today. So what is SSL and TSL? SSL or TSL encrypts communication between a client and server, primarily web browsers and website application. TSL or Transport Layer Security is an encryption which protects data sent over the internet or a computer network. So what is the protocol? It is a communication protocol or set of rules that create a secure connection between two devices or application on a specific network. It's important to establish trust and authenticate the other party before you share credentials or data over the internet. So now you know where it is used, and if we just come to the conclusion, the encrypted connection between a browser or user's computer and the server or website is basically SSL, or SSL is being used there, and TSL is also used for that specific thing. As an example, Gmail is also used, or Gmail also uses the feature of SSL and TSL. Data management. Glacier integrates with Amazon S3, allowing users to define lifecycle policies to automatically transition data from S3 to Glacier for cost saving. Retrieval options. Glacier offers multiple retrieval options to balance cost, and retrieval time. Expedited allows you to retrieve data in 1 to 5 minutes, which is expedited. In standard, it provides retrieval within 3 to 5 hours, suitable for most archive use cases. And bulk data. It enables retrieval of large amount of data within 5 to 12 hours at the lowest cost. It's not as expensive with services which use SSD. Integration with AWS Services. Glacier integrates with other AWS services such as AS or AWS Backup, AWS DataSync, and AWS Storage Gateway, enabling seamless workflows for data archiving and also retrieval at the same time. Vaults and archives. Glacier organizes data into vaults and archives. A vault is a container for storing archives, while an archive is an object or any object, such as a photo, video, or document that you can store in Glacier. So let's check out the use cases of Amazon S3 Glacier. Long-term backup and archive. It is ideal for organizations needed to store large amounts of data for long periods at minimal cost, such as compliance archives, medical records, and even financial records. Disaster recovery. Useful for disaster recovery purposes where data needs to be archived and retrieved in the event of a disaster. Media asset storage, which is suitable for storing media assets like data footage or video footage where raw data needs to be archived for long-term storage but accessed infrequently. Scientific data storage, which is perfect for storing large data sets from scientific research that may not be accessed frequently but needs to be preserved for the data. Overall, Amazon S3 Glacier provides a highly durable, secure, and cost-effective solution for data archiving and long-term backup needs, making it a preferred choice for organizations looking to store large amounts of infrequently accessed data inside of the cloud. Other additions which we are going to learn in this class is that there is two types of glaciers which you will find in Amazon. One is Amazon Glacier and one is Amazon S3. So there is a data storage limit and also a minimum storage duration. In Amazon Glacier of data storage limit, unlimited data can be stored. While in Amazon S3, the same thing happens, unlimited data can be stored. But the difference is in the minimum storage duration. While using Amazon Glacier, you will get unlimited data storage for 90 days. But in Amazon S3, you will get only 30 days. So, in transition, Amazon Glacier transition or from Glacier to only deep archive storage classes. But in Amazon S3, transition from S3 to all other storage classes. The features are already given to you, so you already know about how good Amazon Glacier is. But what is the minimum size of S3 Glacier on Amazon? The minimum size of S3 Glacier or instant retrieval has the minimal or minimum billable object size of 128 KB or kilobytes. And is there a vault in Glacier? It is an archive storage solution independent from Amazon or AWS S3. Instead of using vaults, it uses storage containers, which is opposed of S3 buckets and its own set of APIs for data uploading and also retrieving. As the storage prices is cheaper compared to S3, Data retrieval is more expensive and also time consuming. So, if you have infrequently accessed data which you want to store in the cloud, I would suggest you go for S3 Glacier. It's going to be very helpful for you. So, thank you for watching this video up till the very end and hope you understood about everything in this class. If you have any confusion or any question about any part of this lesson, feel free to ask me at any time. I'm always there to help you out. So, without any further ado, let's move on to our next class of AWS. In our previous class, we've learned about Amazon Glacier and also how Elastic Block Store works. In this class, I'm going to give you out the full brief which you need to know about the AWS security services. So let's get into our presentation. Just make sure not to skip any part because if you do, you might miss out on something very important. So what is the overview of Amazon Security Services? AWS offers a comprehensive suite of security services designed to protect infrastructure, data, and also applications in the cloud. These services help ensure compliance, manage identity and access, detect threats, and respond to security incidents which occur inside of the cloud service, even on your instance. Key AWS security services of AWS. AWS Identity and Access Management, are also known as IAM, which manages access to AWS services and resources securely. It allows you to create and manage AWS users and group and use permissions to allow or deny their access to the resources of your instance or maybe even of your server. AWS Key Management Service, or KMS in short. It makes it easy to create and control the encryption keys used to encrypt the data. Integrated with many AWS services to simplify using your encryption keys to encrypt data across your AWS workloads. AWS CloudTrail. It provides governance, compliance, and operational and risk auditing of your AWS account. Records AWS API calls and delivers log files, enabling you to monitor and retain account activity. Amazon GuardDuty, which is a threat detection service that continuously monitors for malicious activity and unauthorized behavior. It uses machine learning, anomaly detection, and integrated threats intelligence to identify and prioritize potential threats. AWS Config. It provides a detailed view of the configuration of AWS resources in your account. It even helps with compliance auditing, security analysis, resource change tracking, and troubleshooting. AWS Shield, which is a managed distributed denial of service, or known as DDoS protection service. Shield standard provides protection against most common DDoS attacks at no extra cost. So you have zero, you don't have to worry about the DDoS attacks, which also has zero cost. While Shield Advanced provides additional detection and mitigation. AWS Web Application Firewall, or WAF. It protects web application from common web exploits that could affect application availability, compromise security, and consume excessive resource. It even allows you to control how traffic reaches your applications by configuring web security rules. Amazon Macy, security service that uses machine learning to automatically discover, classify, and protect sensitive data in AWS. It also identifies and alerts you to sensitive data, such as personally identifiable information, or PII in short. Personal identifiable information is defined as any representation of information that permits the identity of an individual to whom the information applies to be reasonably inferred by either direct or indirect means. The example of PII, or personal identifiable information, include social security number, which is SSN, passport number, driver's license number, taxpayer identification, patient identification number, financial account, or even credit card number. It can also be personal address or even your phone number. Now, there is also a different data or different thing between PII and also personal data. From a zoomed out perspective, the greatest difference between personal data and PII, or personally identifiable information, is that PII is that often used to differentiate one person from another, while personal data includes any information related to a living individual, whether it distinguishes them from another individual or not. So PII is also, or in cases of, let's say, cloud services, your email, because it is not limited to information such as email addresses and social security number, just like I said. Okay? And in cases of what is not PII, the data that cannot be used on its own to trace or identify a person is not PII. AWS Security Hub. It provides a comprehensive view of your security alerts and security posture across your AWS accounts. It aggregates, organizes, and prioritizes security findings from multiple AWS services and partner solutions. AWS Secrets Manager. It helps you to protect access to your application services, and it resources without the upfront cost and complexity of managing your own hardware security module, or HSM infrastructure. So what is HSM? Hardware security modules are hardened, tampered, resistant hardware devices that secure cryptographic processes by generating, protecting, and managing keys used for encrypting and decrypting data and creating digital signatures and even certificates. So what are the examples of HSM? Such as protection of privileged access and also company secrets. You can also limit the effectiveness of insider threats with HSM. There are basically two types of HSM: general purpose HSM and financial HSM. General purpose HSM is used for digital signatures to encrypt or decrypt information, to verify and validate digital identity, or to generate and custody KPI keys. While the financial HSM can be used to generate, manage, and validate the PIN, to recharge the card, to validate the card, user, and also cryptogram. It even rotates, manages, and retrieves databases, credentials, API keys, and other secrets throughout their lifecycle. AWS Certificate Manager, or ACM. It simplifies the process of provisioning, managing, and deploying SSL, TLS certificates for use with AWS services and internal connected resources. It even allows you to quickly request a certificate, Deploy it on ACM integrated AWS resources such as Elastic Load Balancers and API Gateway, and let ACM handle certificate renewals. So what are the use cases of them? Compliance and governance. It helps ensure compliance with industry standard and regulations such as HIPAA, PCI DSS, and G. Data protection, threat detection, and mitigation security threats in real time. Identity and access management manages user identities and permissions to ensure secure access to resources. Security monitoring and management. It provides a unified view of security alerts and compliance status across your AWS environment. AWS security services are designed to provide robust protection for cloud workloads, ensuring the security and compliance of data and application in the AWS cloud. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AWS. Welcome to a new class. In our previous class, I've shown you about AWS security services. In this class, I'm going to give you out the brief about the services and the use cases of database service provided by AWS. Make sure not to skip any part because if you do, you might miss out on something important and it's going to be a hassle later on when you don't know which model to use. So let's get into our class. What is the overview of these services? AWS provides a comprehensive range of database services designed to meet different application requirements, including relational database, non-relational databases, data warehouses, and in-memory data stores. Here's an overview of the key AWS database services. Amazon RDS are known as Relational Database Service, which is managed relational database service that supports several database engines, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and SQL Server. It also automates tasks like backups, patching, and scaling, allowing you to focus on application development. Amazon Aurora, which is a MySQL and PostgreSQL compatible relational database built for the cloud. It also provides performance and availability similar to commercial databases at a fraction of the cost. It is also seen that it offers features like automatic failover, read replicas, and continuous backup. Amazon Neptune. This is a fully managed graph database service that supports both property graph and RDF graph models. It is designed for applications that need to work with highly connected datasets such as social networking, recommendation engines, and fraud detection. Amazon Document DB, which is managed document database service that provides MonGOB or GODB workloads. Now, what is this? So basically, MongoDB or MENGODB is, let's say, a service or a site which allows a highly flexible and scalable document structure. For example, one data document of a collection in MongoDB can have two fields, whereas the other document in the same collection can have four. MongoDB is faster as compared to RDBMS due to efficient indexing and storage techniques. So what is the DB workload? It is basically a set of requests that have some common characteristic such as application, source of request, type of query, business priority, and or person like performance objectives. It is not precisely defined as a term. It basically means the queries being run against the system and their frequency, volume, or etc. Amazon Document DB also allows you to store, query, and indexed JSON data, making it suitable for content management, catalogs, and user profiles. Amazon Key Spaces for Apache Cassandra, which is managed by Cassandra Compatible Database Service. It also provides scalability and performance for Cassandra workloads without the need to manage the underlying infrastructure. Here, Apache Cassandra, which is a NoSQL database, is the only distributed NoSQL database that delivers the always-on availability, blisteringly fast, read-write performance, and unlimited linear scalability needed to meet the demands of successful modern application. So, what is the use of Apache Cassandra? So basically, it is used to handle vast amount of distribution data without compromising on performance or availability. Its high availability and fault tolerance feature make it a popular choice for organizations that deal with large-scale dynamic datasets. So as an example, what is Cassandra? So Cassandra is the NoSQL distributed database. By design, NoSQL databases are lightweight, open source, non, like let's say relational, and largely distributed, which is also counted among their strengths are horizontal scalability, distributed architectures, and a flexible approach to schema definition. Amazon TimeStream, which is a fully managed time series database service for IoT and operational application. It is also designed to effectively collect, store, and process time series data for events that occur in a sequence. Amazon QLDB or Quantum Ledger Database. It is managed ledger database service that provides a transparent, immutable, and cryptographically verifiable transaction log. It is also ideal for applications requiring an authoritative data source such as system of record and supply chain management. So what are the use cases? Transactional application. Amazon RDS and Aurora are suitable for applications requiring high availability, scalability, and robust transactional capabilities. Big data and analytics. Amazon Redshift is ideal for data warehousing and big data analytics, enabling fast querying of large datasets. High quality or high throughput and low latency. DynamoDB and Elastic Cache are perfect for applications needing high throughput and low latency, such as gaming, ad tech, and mobile apps. Graph applications. Amazon Neptune is designed for use cases involving concepts like complex relationships and queries such as social networks and even fraud detection. Document and JSON storage. Amazon Document DB and DynamoDB are suitable for storing and querying semi-structured data, such as JSON documents. Time series data. Amazon TimeStream is designed for handling time series data generated by IoT devices and operational application. Ledger applications. Amazon QLDB is used for applications requiring a transparent and immutable ledger, such as financial systems and even supply chain tracking. AWS Database Services provide the flexibility, scalability, and performance needed to support a wide range of applications from small web applications to large-scale enterprise systems. So, if we want to summarize what AWS Database Services are, it is basically the broadcast selection of relational and NoSQL purpose-built databases, fully managed, high performance, and ready to scale data. AWS provides other database services including, let's say, DynamoDB key value and document databases for NoSQL database. Even though we only know about a couple, but there are 15 purpose-built database services of AWS. So, including relational, key value, document, in-memory, graph, time series, and ledger databases. This is a model window, but we mostly focus on 8 AWS database services, such as Amazon RDS, Amazon Aurora, Amazon DynamoDB, Amazon DocumentDB, Amazon ElastiCache, Amazon Neptune, and etc. And RDS is only available on several database instances types optimized for memory, performance, I/O, and provides you with 6 familiar database engines to choose from, including MySQL, MariaDB, PostgreSQL, Oracle Database, Microsoft SQL Server, and Amazon RDS on AWS Outposts. So, thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So, let's move on to our next class of AWS. Welcome to a new class of AWS. In this class, we're going to learn about AWS networking services. In my previous class, we've learned about AWS database services, about its brief with a lot of its examples and how it actually helps you in the cloud. So let's move on to our presentation of AWS networking services. Let's check out the overview. AWS offers a variety of networking services that enable secure, scalable, and robust connectivity between resources and the internet within your VPCs and across AWS regions. Here's an overview of key AWS networking services. Key AWS networking services. Amazon VPC, or Virtual Private Cloud. It allows you to provision a logically isolated selection or section of the AWS cloud where you can launch AWS resources in a virtual network that you define. It also provides complete control over the network configuration, including IP address ranges, subnets, route tables, and network gateways. AWS Direct Connect. It establishes a dedicated network connection from your premises to AWS. It can reduce the network cost, increase bandwidth throughput, and provide a more consistent network experience compared to internet-based connections. Amazon Route 53, which is a scalable and highly available domain name system or DNS web service. It can be used to route users to infrastructure inside and outside of AWS and to manage domain resignation or registration and DNS health checks. Elastic Load Balancing or ELB. It automatically distributes incoming application traffic across multiple targets, such as EC2 instances, containers, and IP addresses, including Application Load Balancer or ALB for HTTP and HTTPS traffic, Network Load Balancer, NLB in short, for TCP and UDP traffic, and Gateway Load Balancer or GWLB for deploying, scaling, and managing third-party virtual appliances. AWS Transit Gateway. It enables you to connect your VPCs and on-premises networks through a central hub. It even simplifies your network architecture by acting as a cloud router, managing the connections between all connected networks. Amazon CloudFront. Content Delivery Network or CDN service that securely delivers data, videos, application, and APIs to customers globally with low latency and high transfer speeds. It is also integrated with AWS services like S3, EC2, and Lambda. AWS Global Accelerator. It improves the availability and performance of your applications with global use or global users. Directs traffic to optimal endpoints over the AWS global network, improving availability and reducing the latency. AWS Private Link. It provides private connectivity between VPC, AWS services, and on-premises applications without exposing traffic to the public internet. It simplifies the security of data shared with AWS services and third-party applications. Amazon VPC Peering. It connects two VPCs privately using AWS's network, allowing instances in either VPC to communicate with each other as if they were within the same network. Peering connections can be established across regions, inter-region VPC peering. AWS VPN or Virtual Private Network. AWS also provides secure connections between your on-premises networks or client devices and your AWS infrastructure. It includes AWS side-to-side VPN for connecting on-premises network to VPCs and AWS client VPN for connecting users securely to your AWS resources and directly to your networks. So let's check out the use cases. Secure and scalable network architectures. Use Amazon VPC and AWS Transit Gateway to build secure and scalable network. Architectures that connect multiple VPCs and on-premises networks. Global content delivery. Utilize Amazon CloudFront and AWS Global Accelerator to deliver content globally with low latency and high availability. Direct connectivity. Use AWS Direct Connect for dedicated network connections that offer high bandwidth and consistent network performance. Load balancing and high availability. Implement elastic load balancing to distribute traffic across multiple resources and ensure high availability of applications. Private connectivity. Leverage AWS private links and VPC peering to establish private connections between VPCs, AWS services, and on-premises applications. DNS, and domain management. Use Amazon Route 53 for domain registration, DNS routing, and health checks. AWS Network Services provide the building block to create secure, scalable, and high-performance network architectures, ensuring reliable connectivity and optimized applications delivery across the globe. So, if we come to summary, like if the question arises, what is AWS Network Service? So, the AWS Network Service stands as a colossus in the cloud computing realm, offering an array of service that empowers business to scale, innovate, and secure their digital infrastructure with unparalleled flexibility. Another thing is that you might question like how many network does Amazon have or AWS have? The AWS cloud in North America has 25 availability zone with 7 geographic region with 44 edge network location and 2 regional edge cache location. So, thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So, without any further ado, let's move on to our next class of AWS. Welcome to our last class of AWS course. In our previous class, we've learned about AWS Network Services. In this class, we're going to learn about AWS DevOps Services. So let's get into our class by knowing a bit about it. AWS offers a variety of DevOps services designed to facilitate continuous integration and continuous delivery, which is CI and CD. Infrastructure as code, which is IAC, monitoring, and collaboration. These services enable development and operation teams to work together more effectively, automate infrastructure management, and deploy applications more quickly and reliably. Key AWS DevOps services. AWS Code Pipeline, continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. Automates the build, test, and deploy phases of your release process every time there is a code change. AWS Code Build, fully managed build service that compiles source code, runs tests, and produces software packages ready to deploy. Scales continuously and processes multiple builds concurrently. So your builds are not left waiting in a queue. AWS Code Deploy. It automates code deployments and any instance, including Amazon EC2 instances and instances running on premises. It handles the complexity of updating applications, assuring minimal countdown or downtime during deployment. AWS Code Commit, secure, scalable, managed source control service that hosts private Git repositories. Makes it easy for teams to collaborate on code in a secure and scalable ecosystem. AWS CodeStar. It provides a unified user interface enabling you to manage software development activities in one place. It also integrates with AWS Code Pipeline, AWS Code Build, AWS Code Deploy, AWS Code Commit, and other services to provide a complete CI/CD pipeline. AWS CloudFormation. It provides a common language for describing and provisioning all the infrastructure resources in your cloud environment. Uses templates to model and set up your AWS resources so you can spend less time managing those resources and more time focusing on your applications. AWS OpsWorks, configuration management service that provides managed instances of Chef and Puppet. It also automates the configuration of your environments and allows for consistent automated deployments. AWS Elastic Beanstalk, which is an easy-to-use service for deploying and scaling web application and services. Automatically handles the deployment from capacity provisioning, load balancing, and auto-scaling to application health monitoring. Amazon EC2 auto-scaling. It ensures you have the right number of Amazon EC2 instances available to handle the load for your application. Automatically adjusts capacity and maintain steady, predictable performance at the lowest possible cost. Amazon CloudWatch, monitoring and management service built for DevOps engineers, developers, and IT managers. It also provides data and actionable insights to monitor applications, understand and respond to system-wide performance changes, and optimize resource utilization. AWS System Manager. It provides operational insights and control of your AWS infrastructure. It allows you to automate operational tasks across AWS resources, such as applying patches, managing configuration, and automating instance management. So let's check out the use cases. Continuous integration and continuous delivery of CI or CD. Use AWS CodeLine, Code Build, and Code Deploy to automate the build, test, and deploy processes, enabling faster and more reliable software releases. Infrastructure as Code or IAC. Implement AWS CodeFormation and AWS OpsWorks to automate and manage infrastructure using code, allowing for version control and consistency. Source control and collaboration. Use AWS Code Commit for secure and scalable source control, facilitating collaboration among development teams. Automated deployments. Use AWS Elastic Beanstalk for easy deployment and scaling of web applications, and Amazon EC2 auto-scaling to automatically adjust capacity based on demand. Monitoring and logging. Implement Amazon CloudWatch to monitor applications and infrastructure, set alarms, and take automated actions based on predefined thresholds. Operational management. Use AWS Systems Manager to automate operational tasks, manage configuration, and gain insights into your AWS environment. AWS DevOps Services provide a comprehensive set of tools to help development and operational teams collaborate effectively, automate infrastructure management, and deploy applications more quickly and also lively. So thank you for watching this video up till the very end, and hope you understood about everything in this class up till now. If you have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So let's move on to our class project. Welcome to another class of AWS. In this class, we are going to learn about AWS Code Pipeline. So let's check out the overview of AWS Code Pipeline. AWS Code Pipeline is a continuous integration and continuous delivery CI/CD service for fast and reliable application and infrastructure updates. It automates the build, test, and deploy phases of your release process every time there is a code change based on the released model you define. So let's check out the visual representation of AWS Code Pipeline. Source stage. Input the source code from a repository, an example, AWS Code Commit, GitHub, or Bitbucket. The action is to fetch the latest code which you want to change. Build stage. The input of build stage is source code from the source stage. The action is to compile the code, run the test, and create the artifacts. Test stage. Input. Build artifacts from the build stage. The action of test stage is to perform additional testing such as integration tests. Deploy stage. The input of deploy stage is tested artifacts from the test stage. The action is to deploy the application to a specified environment, in example, staging and production. Detailed example. Source stage. Repository of source stage is GitHub. The action is to trigger the pipeline on every commit to the main branch. In the build stage, the build tool used is AWS Code Build. The actions are to install the dependencies, run unit tests, and compile the application. The test stage is to test tools, AWS Code Build with different configuration. The actions are to run integration tests, perform static code analysis. In the deploy stage, deployment tools, AWS Code Deploy, and in actions, deploy to a staging environment and deploy to a production environment conditional on successful staging deployment. Workflow summary. Commit, developer pushes code to GitHub. Trigger, pipeline detects the commit and triggers the pipeline. In build, code build compiles the code and runs unit test. In test, code build runs integration test. In deployment or deploy, code deploy deploys the application to staging, then production. The description provides a basic understanding. Welcome to Class Project 1. The name of the class project is How to Open AWS Platform. I have attached in a description and also an outcome. In our description, we can see AWS, or Amazon Web Service, is a comprehensive and widely adopted cloud platform offered by Amazon. It provides a broad set of infrastructure services such as computing power, storage option, and networking capabilities, delivered on demand and on a pay-as-you-go basis. So let's move on to our steps. The first step is open any web browser which you have on your device. It could be Google Chrome, it could be Mozilla Firefox, Microsoft Edge, even Opera browser. Step 2. Go to this link of https then at aws.amazon.com. Step 3 is create an AWS account. If you already have an AWS account, just sign in. Step 4, once signed in, go through the AWS Management Console. In step 5, take a screenshot of the console and upload it into our project panel. So what is the outcome? By learning how to open the AWS website, or aws.amazon.com gives you access to information about the AWS services, products, and also its resources. You can explore service description, pricing, and documentation, and manage your resources through the AWS Management Console. if you log into your account. So let's open up our web browser as our first step. As you can see on my screen, I have opened up Google Chrome. Now search in for AWS Amazon. Hit on search, or you can also search in for aws.amazon.com. It will take you directly inside of the website. Now make sure that you are connected to the internet. Is going to give you the best result. When you open up aws.amazon.com, you'll basically see an interface like this. So from here, you can also contact an AWS specialist, or you can just get started for free. So what you're going to basically do is first off, get started for free, and then you're going to click on create a free account, which is going to be AWS free tier. You can also create an AWS account from this one over here. But if you already have an account, you can just sign in. Let me show you how you can create yourself an account as an addition. Click on create an AWS account. It will redirect you to another platform from where you'll be able to create yourself an account. And you can see these are all of the top product categories. You can see compute services, database services, storage services, container, web or mobile application, serverless ones, machine learning, and a lot more. There are going to be also different type of storages and also different type of subscription models. So basically, after verifying your email and also maybe your phone number and also putting in your password, you will basically see this option over here or this page over here where you have to sign up for AWS with your contact information, with your name, country code, the region, address lines, and all. And after that, you're going to just select on this and continue that again. Then after finishing that, you'll basically see this one, sign up for AWS. Then you're going to put in your country, then your credit card or your debit card number, expiration date and stuff, and cardholder's name. And after that, you're just going to use that. And then you can verify that after you are done. So basically, after finishing all of your logins and stuff and your cards and setups, you'll basically find out something like this about AWS, the console, the products. You'll be able to go through them. And after you're done, you're just going to take a screenshot of your account or maybe just a screenshot of the platform and then just upload it onto our project panel so that we can understand that yes, you are progressing with work and now you know how to get inside of this platform. So thank you for watching this video up till the very end and hope you understood about everything. And without any further ado, let's move on to our next class project of AWS.